Okay, 1, 2. 1, 2.
put it behind the speaker, but maybe towards one of the sides. Yes? Thank you very much. I'm next to the speaker here. How about that? So you're, yes. That's why I'm preparing. Maybe on the side, behind, yes.
Hey, hey.
Hi, Robert. How are you? Yes, very good. Yes, yes. Okay, very good. So the keynote is about to finish. It's literally like a 30, maybe 1 minute away. But it's good, yes. Yeah, working. Yes. Yeah, yeah, I know. I understand. Okay, very good. So thank you for letting me know, Robert. I appreciate it. There you go. Do you hear the clap? Schedule. Yes. Yeah. Yeah. Okay. Yes. Okay. Thank you, Robert. Yes. Okay. All right. Thank you. get mic'd up. Yes, my friend. Can you read my mind? Were you reading my mind? Yes. Very good then. Luck doesn't come into this. This is a. But thank you. I appreciate the.
You seem very nervous.
Do I? Me? I think I've done this before. It's okay. Yes, testing 1, 2, 3. Yes. I know. Testing 1, 2. Thank you. What makes me nervous is the additional challenge of giving a talk, and you're responsible for many things happening.
I know that's
nervous. So usually you just come, you give a talk. Oh, testing 1, 2, 3.
Test, test. Hey, die werkt. Kom zitten in de front.
It's a process. Getting alignment with putting standards in organizations.
Join us in the front, Katie. Yeah, I see you. Join us in the front there. No. Oh, good luck. One more minute. Yes, I know you are. I know you are. It's a strong spotlight.
Sorry?
It's a strong spotlight. Yeah.
Here.
Oh yes.
You need to keep me on track.
Yeah.
I'm notoriously good at
This
very
was
short.
10 minutes. 5.
5-1.
5-1. Okay. Yeah. All right. I think we can start off with this morning track. It's a general track with a combination of different topics, but actually the first two talks are going to be, or presentations are going to be MATLAB related. So let me first introduce the first morning speaker for this track. His name is Gareth Thomas. Maybe actually interested. Show of hands. Who knows who Gareth is? It's not too much actually. So
Only on that side. Those are my friends.
yes,
And
yes,
these will
good,
become
good.
my friends.
Yes. So actually, not related to the topic of the talk, but more Gareth is actually has been very crucial in making both PyData and JuliaCon happen here in Eindhoven, because he's been basically involved in organizing meetups for the past 3-4 years or something like that.
MATLAB,
So-
Python, and Julia.
MATLAB, Python, and Julia, and yeah, so it's really great that he's able to give this talk here as well. In preparation of in the lead up to this, we've had plenty of discussions on the Julia side of MATLAB versus Julia and all of the different conversations. Those discussions lasted, I think, in the hours, maybe even. So I'm very curious how you'll be able to summarize that in 30 minutes. So here you go. Give a round of applause to Gareth.
Thank you very much. Good morning, everybody. How are we doing? You enjoying the show so far? Yes? So just a quick hand raiser. Who here actually uses MATLAB? So you all use MATLAB. Which conference are you guys in? Okay, good. Okay. Who here actually? The first user in the user. So I'm going to shake your hand, sir. Thank you very much. Big round of applause. So this is cool. That's kind of unique. I wasn't expecting that. So my name is Gareth. I'm going to be talking about my first 10 hours in Julia, right? So I actually, to understand my talk, you have to understand I used to work for the MathWorks. So I spent nearly 10 years of my life working at the MathWorks. So it kind of shaped a lot the way I think and see the world. That being said I left the MathWorks, created my own company. I have 2 kids, and I've always wanted to create my own company. So I said, okay, I now have learned as much as I can from the MathWorks. I'm going to go and create a company. Created a company, and what we do is we're a bunch of MATLAB, Python, and Julia consultants, right? Okay, and my screen disappeared. Okay, very good. So I really only have for this talk to kind of 5 things that I want people to remember, right? Typically it's 3, 5, odd numbers are good. So number 1, independently of MATLAB, Julia versus, I think curiosity is key. Everybody should be curious, right? 2, respect language diversity, right? 3, listen before prescribing. 4, don't ask how can I, ask what is the right way to. And 5, turns out that learning is an investment. So why did I choose these 5 things? Well, it turns out that tools and languages are always evolving at an ever-fast pace. The only way we keep up, we stay curious. And it turned out by learning Julia, or exposing myself to Julia, it actually solidified a lot of concepts that I thought I knew in MATLAB, and I wasn't really sure about it. So it triggered me to think more about my own understanding of the place where I was most comfortable, okay? And it's very interesting, when you speak to Julia folk, they say, Julia's super fast. But that only matters if MATLAB is perceived to be slow. So here's a question. Is MATLAB slow? So don't say Julia's fast to MATLAB users. It doesn't work. That doesn't solve anything, right? Just like doctors. Listen to why people don't like the language or want to change, and then it's better, right? And then it turns out that to be good at the new language, It's very, very common for engineers, just get it working. It's working, we move on, right? But we never go back and think, well, what would have been a better way of doing it, or what is the right way of doing it, right? So mastering a new language, there are gotchas in every language, and it takes time to master those. And because it takes time to master them, you got to make your peace. If you're moving from one language to another, it's an investment. Make your peace and say that we're actually going to be not as efficient as you used to. So I was a strong MATLAB user, and then when I started using Julia, my productivity went down, down, down. I don't care what people say. It went down because it's like, yeah, there's all these gotchas that is like, I have to Google more. Oh dear. Okay, Google, help me out. How do I do this, all right? So these are things I want to take away. So a bit about myself. I'm a control engineer. I studied in Portugal, worked at Siemens, worked at the MathWorks, and I created my own company, Version Bay. What am I going to be talking about? Change, right? MATLAB versus Julia. I think it's about understanding the two ecosystems and figuring out which is the best one for your tools. When you look at organizations and people looking to shift between things, you need a vision, you need skills, incentives, resources, and if you get that, change happens. If you miss some of them, you start noticing people get anxious if they don't have the skills. If you don't have the incentives, things don't move fast enough. So I'm focusing a bit about the skills and the incentives here, all right? High level, scientific computing journey. You can see yourself as a newbie, someone who's just starting, maybe a casual user, maybe someone's proficient, or maybe someone actually developing tools for others, right? There's a spectrum of how good you are in languages that we all go through this journey, right? Turns out each of these categories of folk feel and struggle with different things. I consider myself a MATLAB developer because I've worked a lot with it and I help building tools for others in the MATLAB ecosystem. So I said to myself, I'll start with Julia. I'll be proficient. I mean, I'm a smart guy. How hard can it be? Well, it turns out that this is much more realistic, right? I am a newbie in this. So remember, this talk is my first 10 hours in Julia, and I'm sharing all the things that caught me off guard, which I think are useful for others to be aware of, all right? So enough of slides. Let me talk a bit about the problem I want to solve. So if I'm a newbie, right, how do I get started? How do you get started in Julia? Well, install Julia. Okay, great. But that's fantastic, install, okay. But then here's, well, what problem do you want to solve? So starting thing is I want to explore Julia and plot a 3D sine wave and have a function that has an input of frequency, right? This is like as basic as it gets. If I can do this, great. But I want to walk you through what that looks like. So how do you do this? We start the REPL and let's try VS Code. All right, so congratulations, we're in the terminal. So let's do this, cd demo 1. Okay, so you start Julia. You've installed Julia. Great. This is fantastic. All of a sudden I'm lost. My key things that I start over don't work. Okay, so how do you do this? So it's Control L. Okay, I can clear it. But it caught me off guard because I didn't want to see Julia, I just wanted the prompt, right? Okay, so how do I plot a sine wave? Well, actually, before I do that, in Julia, there's a couple of things. You have this REPL that changes based on the commands. It's kind of cool. You have help. You can have access to the Julia command prompt. You can add packages, the package environment. For the Python folk, that's kind of a weird thing. The pip install env, it's always kind of confusing. Julia integrated nicely. But I'm going to actually do activate dot. What is this? I just created an environment. That's kind of nice, right? Now, let's do a bit of programming. T equals. So far, so good, right? Yes, good, we're nodding. Now, I want to plot a sine wave. Y equals sine of t, right? Does anyone find this weird? Okay, so what went wrong here? First MATLAB user on the planet. What went wrong here?
The mathematical definition of sine works on scalars.
But I abuse that. Wow, okay. So I'm not the first MATLAB user, but what does it say? Method error, no method matching sine, step, lane, float 64, base, twice precision, float 64. How do you debug this? Okay, so there's a help, sine. Okay, so there's a few examples. Still not clear. But then it turns out that there's this funny thing, which is actually pretty powerful once you get it. It's the dot. It's broadcasting it. So, okay, so you look at this, and then what you really want to do is sine of dot of t. Okay, that works. Great. So now I understand, right? So the way that instead of writing a for loop, Julia does this broadcasting in because sine mathematically represented as a scalar.
By the way, Clete Muller, the inventor of MATLAB, used to pronounce .NET as broadcast, but as pointwise. It's a point. It's a decimal point.
It's a decimal point.
So it applies pointwise.
Pointwise, yeah.
So even though MATLAB doesn't do sine dot, Cleve invented the sine dot anyway.
Funny how the world goes.
Yes.
But it is interesting, as a MATLAB user, this caught me off guard, right? So now what do I want to do? Plot, right? What's missing? Oh, I need to add my plots. Okay, now that I've added my plots to my environment, right? So now I go using. So you want to use a package, you have to know this. Once you get used to it, it's fine. Great. Okay, cool, it works. But it's not very flexible, right? Doesn't move, scrolling, that's not so nice. Okay, so now what? I don't know. ChatGPT, maybe? Or can we do this? This, I think, is a realistic scenario, right, in today's days, right? Is this a reference of golden truth? I don't know. Oh, add plots. I got that one. Good. Well done, Gareth. Example data. Yes, I got two vectors. Kind of right. Really? Plot x, y, z, series, surface. Okay, that looks a bit clunky. Is that what I really need to do? Not sure. So let's see if I get this. Why don't I do, first I need to get a mesh, right? So let's see how this works. Does this work? No, because I need to transpose it. Yes, we agree. That makes sense. So do I want what? Y times y transpose. Does this work? Okay, that's not exactly what I wanted. So I kind of say, well, maybe I want a surface. Surf, so I come from the MATLAB world. Does surf exist? No. So tab completion. Oh, surface. Okay. T, and then let's do y times y. Good. Okay, good. We're rolling. This is good news, right? It took me 5 minutes to get this, right? It's a bit of a thing. So this is an experience which I think is kind of interesting. But then there's another thing of like, but I still can't move it. So how do I fix that problem? You go to plots, and you say, oh, plots. And there's different types of plots. Oh, I can use Unicode plots. What's this? Does this work? So if I do that, Unicode plots, does it work? Oh, no, I need to go here, add Unicode code plots. So double tab helping me out. I need to add a package for this to change the backend. Hold on. I'm going to change the backend of plotting? That's possible. It's kind of cool, right? So let's try this again. We go up to our history. That didn't work. Why? Because I need to tell it that I want to use it. Wait for it. Sorry. Good. Kind of cool. So it turns out there's a whole bunch of ones there, right? Unicode, not so important. There's a whole bunch of them, Plotly.js, and you can kind of do things. But you need to know this, right? So there's a bit of searching that is involved to do that. But there's a few other things that kind of caught me off guard. Is you can also say f of x equals sine dot x. I just created a function here, right? That looks pretty elegant. I like that. That was sweet, beautiful, elegant, like a mathematician would think, right? And there's other things, and just because my title is an interesting title, I'm going to do something cool, which is this. Let me see if you find this funny or not. MATLAB equals 1, 2, 3, right? And if I say Julia equals sine of x, let's do this. Okay, what I can say is Julia MATLAB. That makes sense. But it turns out most of the planet reads left to right, not right? So you can actually do this. It's kind of cool, isn't it? No, people didn't find this funny? You did find this funny. Okay, so the first time I saw this is, what on earth is going on? So I had to Google it. I didn't know what that sign meant. I don't even know what this right term is. Is this the pipe command? No. Pipe, right? So I was like, oh, the piping looks nice. That's kind of cool. So these are just a few things that kind of caught me off guard as a newbie, right? So let me walk you through that. Am I clear? That hurt me at the beginning, but okay, that's a small thing. The REPL's got a whole bunch of things which I wasn't used to. So it's got for package management, environment, access to the shell, documentation. Using plots, if I'd done this, it will prompt you that don't forget to install your packages, which is kind of nice. I like that a lot. My osign.t, that caught me off guard. Once you know, it's okay, but it's that first few hours is like, oh, don't know. What did I do wrong? What did I go wrong on that? The 2pi, I don't actually need to do 2 times pi. I can just say 2pi. That's kind of sweet. I like the way that the functions are written. It's kind of like how a math teacher would teach it. And yeah, the piping was cool, but I had to Google what I was doing it, and I felt very proud of myself. I felt like I've achieved, the next badge in my Julia journey and whatnot, right? So those are some of the things that caught me off guard. Now, if I go to the casual user, so how am I doing for time, Irvin? How many minutes have I got left?
About 10.
10 minutes. Okay, cool. So we're going to do something super cool here. I would like to inspire my 5-year-old to use a new programming language. How do I do that? Python world uses Turtle, so let's use Turtle. Does everyone know what Turtle is? Good. If you don't know what it is, I'll walk you through it. And I'll show you how this is done. So I discovered Pluto. What is Pluto? Okay, so this is kind of an interesting thing, right? So if I do this, I didn't need to do it like this. I could have done it in Julia, but I'm going to do it anyway. Julia. I'm going to go activate my local one. Just so you know, I've already pre-installed Pluto, right? What is Pluto for those of you who don't know? You do import Pluto, then you do Pluto run, right? So this is kind of like similar, I guess, to the MATLAB live scripts in some shape or form, and I'm going to create a workbook, right? So this is maybe like Jupyter Notebook, but Pluto is a little bit different. So let me do a quick little example here. Use a few packages, Luxor, colors, and I'm going to use Pluto.ui. Oh, good point, good point. I should have prepared for this. Does that work better? Thank you very much. So I'm going to import some things. It's going to do it in the background. I'm connected. So Pluto makes life easy. It takes away the adding packages behind the scenes. And I can define a variable, so that's great. You have these cells. I can say y equals like that. That's kind of cool. But what is super special about this, kind of cool, is I can change this number. Look what happens to y. It got updated automatically. See that? And here's another cool thing. It actually doesn't matter the order. Did you see that? Nice. Feels like Excel again. Excel does this. Okay. A couple of things. Okay, so then you can do, oh, sorry. Bear with me. Oh, I did that. Variable not, okay, yes. Okay. I apologize. What is my next step that I want to show you? How about this? MD triple dot. This is a slider. Okay. Dollar bind X slider 180 default 80. I think I got that right. And I'm going to do this. It's kind of cool. Oh, I missed my X. See what's happening to my Y? That's smooth, very responsive, right? Why is this interesting? Okay, so function, my turtle. I want to show you the turtle thing. Bear with me as I type this. Drawing, live docs, let's show this. As I tells me exactly what I need. Okay, origin. I want to draw turtles. We'll get there. Bear with me, all right? Right? T equals turtle. I want to go forward. T, 100. I want to turn. T, 60 degrees. Forward. T, 20. What do I want to do? Finish. Preview. Why am I doing this, you might wonder? I just defined a function, and then I can call my function, right? My turtle. Where did I make a mistake? Sorry? Forward there. There we go. See what happened? I moved, put a turtle down, moved 100, turned my angle and went down, right? Why is this kind of cool? I guess you can see where I'm going with this, right? Angle, right? Let's remove this. Let's do some, because Irvin said I had only a little bit of time.
So 5 more minutes and then questions for 5 more minutes.
Very good. Let's do this. +1, and I'm going to angle. I think you're all following what I'm doing, right? That's kind of nice. Define my function. Oh, my turtle's not working. Why? Because I need to give it x. Did you see that? So let's hide a few things. Actually, no, let's bring this up to the top. Let's do this here. This is the image. Look at my slider bar. Isn't that cool? You can change the pen with the colors, you get it, right? That was nice. This is how I can draw cool things. That was kind of elegant. But you could argue that there are more things, right? So this is just a starting point. My discovery here was Pluto. It took me a while to figure out its existence. Once I did, this was a much easier way to get started. So I'm going to go back to my slides now. And I also used an example of data frames. So MATLAB has tables. Data frames in Julia are very powerful. But you have to get your head around them a little bit. So remember that piping idea? The data frames work a lot with that, so that makes it interesting. So if you read this line, first, unique, sort, data frame, join, group on, right? It's actually easier that I'm taking the data frame, these 2 columns, I'm sorting it, I'm looking for the unique, and I'm looking for the first 10 elements. I think it's arguable that this is maybe easier to read for the first-time users, all right? There's a thing that caught me by surprise, that for loop. If you do this for I equals 1 to 10, you print the I, that's great, but outside the for loop, the I disappeared. The variable disappeared. It's out of context. It was like, what on earth happened? It disappeared. Where did my I go? It took me literally 20 minutes to figure out that that's a thing in Julia. So context makes an important difference, right? They've also got the transformation stuff. So anything that MATLAB can do, pandas can do, data frames can also do. That's great. You just need to get used to it. But I did like the slider bar. That widget was cool. MathWorks also has it, but I think I found this a little bit more responsive, right? That drawing was pretty slick. The order, that's a nice touch. That only applies to Pluto, not to other things. So really cool things that happened. I think Pluto surprised me. I was not expecting that, but it took me a while to discover it. Just as a sanity check, then it's okay. This is not just playgrounds. I'm a control engineer. I try to use it with a control example. At the MathWorks, I always used to use a PID controller, and I would do auto-tuning, and it turns out that Julia has the same thing. Very clear, very easy to use, and I was very impressed with it. The way that this works, you can use Visual Studio Code. Let me show you how this works, just as a quick demo. I know I've been given the card. Bear with me. Visual Studio Code, using control systems, Control-Enter. It's running, loading the control systems package. And I'm going to use plots. Great. MBK, this is a mass spring damper example, the classic one that all control engineers use. Notice as I tick through what's appearing here in my REPL, I got a transfer function, I create a PID, just created a feedback loop. I'm going to do a plot. It appears. I'm going to use loop shaping PID. This is the auto-tune. Let's do the feedback loop again. Plot. Oh, I just automatically tuned a PID. That's pretty cool. Yes? And it actually gives me nice little additional graphs for free. So for a control engineer learning out, I would argue it checks off a lot of boxes. So it's not just for playing, right? The documentation is pretty good, and I like that. That surprised me. So as a control engineer, I was like, oh, there's something here. Some of these packages are deeply thought out. Problem 4, it's all about sharing things. I won't go into too much detail. I'm the author of jokes.jl, because in conferences, in these awkward silences, I like typing jokes. Use it, give me feedback. It's kind of fun. Can I do this? Okay. So I'm going to stop this for a second. This is self-proclamation using jokes. That's what I created. I mean, that's as far as I got to deploying it. But I wanted to just see the workflow to deploy a package. Is this kind of funny? There's no why, so I created my jokes. Okay, very good. Never mind. But the interesting thing about that is actually the process behind it. I think the Julia community has done it really well. The packaging, I think, is well thought out of. The test, the way you write tests is a little bit different, but it works, and it's kind of forcing you to write tests, which I kind of like. The documentation out of the box happens nicely when you publish a package. The documented JL makes life a lot easier for doing that, and I appreciate it. It looks consistent. And the other thing is when I published jokes.jl, it took me literally 24 hours, and some dude, Benoit, maybe some of you know him, he looked at my code and said, dude, that's not how you write code. What? What happened? So let me show you. This is me as a MATLAB user. How did I type that? So maybe this was not the best example, but I was tired and I created jokes, random. No, and then Benoit said, dude, just do rand jokes, right? Maybe I should have just read the documentation. But it was nice that the community stepped up and helped me teach me a little bit more, and I was appreciative of that. So it turns out that it's not as hard as you think to create a package. It's very nice. Modules are important, but you have to use include, so there's a few gotchas in that. Testing and test items is nice. The community helped me, and the tag block automation documented.jl really makes life easy to publishing packages. I'm very grateful. So on that happy note, I'm going to ask you quickly, what were the 5 things that you were supposed to remember? Sorry? Jokes.jl is not what you were supposed to do it, but if you give me a star, I'll be happy. So I want to end this talk very quickly saying, curiosity is key. Don't be scared to be curious. Look over the fence, see what others are doing, and think about it. Be critical, right? The other thing is respect language diversity. Seriously, I learned things from Julia, but it solidified my MATLAB knowledges by doing that. And I think the same holds true in both directions. Listen before prescribing. If MATLAB is not perceived to be slow, stop saying Julia's solution is fast, and that's why you should use it. That doesn't help. And I think it's why should we use Julia? So we'll get into the questions just now, Paula. Let me finish the 3 points, and we'll take it. There's a microphone that will help you. All right. Last thing is ask how to do the right thing. So Benoit taught me how to write better code. I'm grateful. I should have actually, at that moment, before I published, take a step back. There's got to be a better way. That looked ugly. I should have thought about that. And learning is an investment. So with that, thank you for the talk, and let's take the questions then. Very good.
So I will ask you, like I did not hear the previous workshop.
Okay, very good.
He actually gave already a hint why we should use Julia, but asking you why.
So
Why Julia?
So this gentleman here says the cool people are using Julia. So that's one way of doing it.
Just to be cool, then.
I think languages come from different backgrounds, right? So MathWorks grew from a particular area. Engineering, science, electrical engineers kind of learn about it. I think Julia has its strong suits, not necessarily in engineering, but more mathematical-minded folk. And as the community grew, it also expanded into different domains. So I think there's certain problems where I think Julia is really good. So the mathematical computation in some places I think is really fast, right? I think the power of going to GPUs on all architectures, MathWorks doesn't support all of them necessarily. The GPU, high-performance computing, the Julia community solves that. And I think their strength is really downstream. So it's not at the beginning, but if you're a developer, a scientific-minded person, developer who thinks about these things, Julia is actually very attractive. But for newcomers, it's a bit of a journey to get there. And I think the MathWorks kind of does it the other way around. For newcomers, it's a much more embracing feeling. But then if you want to go to high-end things, maybe outside automotive or aerospace, or you're not doing safety-critical applications, then Julia is actually okay. But I mean, every car we drive, every plane we have, it's got some MATLAB behind it. So respect language diversity, right? It's something cool that the MathWorks did. I think the Julia could take a few tricks from that, like certification, deployment. There's some cool things there. Yeah? More questions?
In the meantime, if the next speakers can...
Yes, next speaker. Next speaker needs to come up and sit on the computer.
And I see a question from Mark in the back.
You mentioned that you like the documenter.jl, but
Yes.
I think it's the getting to the documentation is not as smooth in Julia, I feel, as it is in MATLAB.
Well, so I think the MathWorks has actually done something very cool. Is their documentation, I think it outranks everyone. I think it's an inspiring example, right? The examples, the thought process, the manpower they put in, it is great. But when it comes to publishing a package as a developer, you wanting to integrate into that. It is, I think the Julia community's put a bit more thought of how should we tell our developers, package developers to do so, and they're giving a bit more guidance. Whereas I think the MathWorks doesn't do so much guidance there. There's clearly documentation, you can do it, but it takes a bit of time to get your head around. But the Julia community did very nice is they put it on the CI tools, right? So when you tag, create a package with documented the tag box, that process can be generated automatically. That's not as well documented, I think, in the MathWorks ecosystem. And if you look at file exchange, where there's a platoon of things there, they're not as well documented or consistent in the same way the Julia community has been doing. But I will say, the MathWorks documentation, once you integrate it in, it's kind of cool, but it does change every now and again with its releases.
Right. I think I agree with you on the point of user-generated documentation or
Right.
you know, or package developer generated documentation. But what I'm asking about is accessing documentation, right?
Sorry?
What I'm asking about is accessing documentation.
Oh, accessing documentation.
Because right now in Julia, right, I just do question mark, but I get this thing in console.
You
right?
saw me do it, right?
As
It's like,
opposed to getting it into an HTML browser, right?
So I will agree with you. I think the last final parting thing, I think if you look historically, one of the things why people were drawn to the MathWorks is their documentation. I think if the Julia community could get as good as the MathWorks, that would help the community in general. Final parting thoughts. Thank you very much.
Take a sip of water if you want.
No, because we will do demo, but I will take this, and it will. Can you also use the? I can switch. Yeah. Okay. Wow, you're so professional with this one. Sorry. Long hair.
What? Oh, thank you.
Right, just all right. Just checking if you're audio.
No,
Perfect.
let's do how we said.
Yes. All right. Thanks to the
So-
great sequencing of the program team, we have another MATLAB and Julia talk coming up by Paolo and Joris. So please take it away.
Thank you. So, my name is Paolo, is Joris. We are both functional design engineers at ASML. We are working in a leveling department, and today we want to present some work we've done in order to allow MATLAB to be more integrated with Julia, essentially. Which is actually, I think, it channels very well with the introduction given by Maurice in terms of bridging languages, allowing interconnection between languages, and so on and so forth. So I will outline a bit the presentation that I'm going to give. So I will give a bit of background why we're doing this and what is problem that we're trying to tackle in ASML. Then I will briefly show the solution that we come up with, and briefly how it works. I won't go too much into details, because then I'm pretty sure that everything that will be unclear up to that point will be cleared during the brief demo time, and then finally there will be some conclusion about all of this. So let's start first with a single sentence that encompasses the whole thing. So essentially, MathFrost, which I will go into detail later on, was called Bifrost, but I will get to that. MathFrost essentially is a Max library that connects Julia to a MATLAB API. In other words, it's just a data marshalling library. As what we do, essentially we act as an adapter between two languages, in this case, MATLAB and Julia. Now, of course, the question is, okay, why? The problem is the following. As was already introduced by Maurice this morning, we have multiple languages that must be interconnected in our daily workflow in ASML. So we daily use all three of them. There's also Java and many others, I'm pretty sure. But let's put it in this way. MATLAB, C++, and Python are the ones that are the most well developed and interconnected to each other. Whereas Julia, which is the new language in town, has to be yet tightly integrated in the workflow. When I say tightly, I mean that there are still some ongoing challenges when, for example, we are talking about data interchange, data exchange, and allowing, for example, to load blob of data from C++ to Julia or the other way around. It's an ongoing process. As I said, the data marshalling part of in ASML is quite difficult because if we want to integrate Julia, Julia has to work flawlessly with every single possible language that we use. Since this is not yet true, at least 100%, this essentially slows us in terms of adoption. New possibility. We cannot hope to integrate packages that lies in the Julia hub if we are not sure that the interchange information between component is smooth, so to speak. And of course, since we are dealing with MATLAB, and we would like to adopt things that not necessarily MATLAB at the current point in time provides, we have a lot of legacy that we need to tackle. We came up with the following solution. So we had a bunch of requirements that we needed in order to while we were deciding how to develop this. So the first one is we don't want to disrupt the existing code. Essentially, developing is like I put this image of essentially changing a tire while driving down the road. And this is, I think, that describes very well the development process inside the big corporate companies. Of course, the other problem is the data marshalling part. We cannot hope to have multiple technologies communicating to each other if there's no communication. And finally, and this kind of feedbacks on what the previous speaker talked about. We also would like to see more people trying this language, because there are multiple positive things about Julia that we would like to essentially incorporate in our daily workflow. So after all of this, then we came up with our little package. So, and this is where I explain the Bifrost, Mathfrost naming collation. Initially, this package was named Bifrost. Unfortunately, as I will explain, we were kind of scooped on the name. But so Bifrost, to briefly explain what it does, where it comes from. In Norse mythology, Bifrost is just this mythological bridge that connects lands of humans and the realm of gods. Although it was ripped off by Marvel, it doesn't belong to Marvel. And, well, unfortunately, we don't have a logo yet. And as I already said, we will have to we pivot to a different name, and this time we decided to merge Bifrost with MATLAB to some extent. So essentially, we came as Mathfrost. So this is why the slides were referring to Bifrost, but we meant also Mathfrost. Anyway, this package essentially allows us to do the following things. It allows us, first of all, to introduce Julia in the daily MATLAB workflow in a really, really neat way that will be explained by Joris in a bit. And the thing that is probably different from all the solutions that I know of out there that does similar things to our package is that essentially allows incremental migration, which means you have an existing code base, might be very large, very small. But the point is, what this package does allows to intercept the symbol name. It might sound a bit abstract, but I'm pretty sure that it will be pretty much clear after the demo. Essentially, what I'm trying to say is, potentially, if you have a large legacy code base, you can convert a large part of this code base, assuming good coding practices, by simply dropping the package and creating the right connection between symbols, which is something that I'm not aware of that other packages are doing at the moment. Again, this is what I've talked about so far. So we wanted to have a strategy that allows us to move data between Julia and MATLAB as transparent as possible. And finally, we would like to try new technologies. So this essentially allows us to borrow packages from Julia and integrate them in MATLAB in a very transparent way. As I said, we are very well aware that this is not a novel idea. This approach has been tried in the past. However, because of our legacy code, because of things things were being developed in ASML, the solution that I found, and this is, I guess, just a small subset of packages that provide similar services, they don't fit our use case for the following reasons. So either the calling direction is wrong. So we implement a package that allows MATLAB to call Julia, but we don't do the other way around. We don't care. And this is already exclude some of the packages in the wild. The second point is related to the incremental conversion of code. None of these packages works in the same way that we do. Because in order to call functions, foreign function, in this case Julia, or MATLAB for some packages, you need to use strings. Strings are not symbols in the same way that we will show in the demo. Finally, there are some performance problems related to how things are achieved in these packages. I don't want to do a compare and contrast. These are pretty good packages. This is not the point of this slide. I just wanted to underline that what we are doing in the way that we are doing is slightly different, and this is why we created it. So I will briefly go through how it works, and this is essentially will allow you to allows to Joris to explain and with a demo how it looks like. So essentially, we start with the basic MATLAB process. So you have your MATLAB instance running on your laptop or your computer. What do? We create a new max host, which is the MATLAB way of saying, and pardon if I'm taking creative licenses for this, but essentially it's the MATLAB way of saying we are forking the process. Then what we do, we load our max, which is our Bifrost. It's mainly composed of two components. The thin interface, which is the one that allows us to do this symbol hijacking that I was talking about, and all the data marshalling, since we want to be as performant as possible and also future-proof, because this has the upside of allowing us to develop a code that, unless either MathWorks or Julia don't change radically the API, we can follow the development of MathWorks and stay up to date. Finally, our Max load Julia into memory in the Maxos process memory, and after we've done this, essentially we allow MATLAB to send information to Julia. Julia does his own computation, and then we get back the result to MATLAB. When we apply it to just a very bare function call, I wanted to just explain it a bit more in detail, but essentially the core part that I would like just to underline is we developed this little package in order to be a kind of extensible. So everything is composed in two components. One is some kind of a way to describe types, abstract types in C++, and the other one is essentially what really perform the conversion from one realm to the other. But again, let me show you more or less how it works, and then I will let Joris to continue with the demo. So let's suppose that we have run, we have loaded our Bifrost in memory. This is like a preview of what we will do. But essentially, what we have achieved is the following. We have this component, which is we're referring to the thin layer of code that allows us to communicate more transparently with Julia. Then we define a function in Julia. In this case, it's just a function that does nothing more than complicated than adding a scalar to a vector. So I put it only there because then when I will go forward, essentially what you expect from MATLAB is to see a vector that has the components 2 and 3, because we added 1 to a vector of 2 and 3. But the key point in this very brief slide is that there are no strings. So what I'm trying to say is the name of the element, the symbol marked in green could be sine, could be cosine, could be any function that actually lives in MATLAB. We can hijack it and substitute with Julia code transparently, because the idea is that once you define the symbol, you can intercept the behavior of the code. But I hope that I made myself clear. But I will leave Joris for showing the demo. Can we?
Hi.
Test, test. Yep.
Hi. Yes. My name is Joris, and I will be giving you a brief demonstration.
Yeah, actually.
A brief demonstration of that's fine.
No, okay.
A brief demonstration of how the user would interact with Metros, because I think it's quite an user-exposing package. That's why I composed a few examples. So in this case, we start off with constructing a Julia process with Metros loaded. Sure. So we start off with opening a Julia process, which opens a max host, which is a new process controlled by MATLAB itself. So we open the process with a certain environment, which is our project environment, which is now linking to the Metros JuliaCon demo, Julia project environment, and we dive into the package Metros JuliaCon demo, which is this module. We now have an example where we show that we can map MATLAB objects to any kind of Julia data type. So in this example, we have a structure of a country that consists of a vector of cities. So we show both arrays, and we show also composition of types. On the MATLAB side, we take, for example, the Netherlands, and we took 3 cities: Amsterdam, The Hague, and Eindhoven. Each city has a name and it has a population, which is roughly the population in the thousands. And the vector of cities will then be composed into an object of a country, which has a struct of cities and some area with some random number. And if you would run this, so in the first function, what we're doing is we're running, we find the total population, which is just the sum of all the population for each city. which is the function that you see over here. We have as input we put in 920, 565, 246, and it should sum to 1731, which you see over here. We do everything in their actual type, so that's why we don't return doubles, but actually int64s. And to also show you a little bit more of the Julia side, we did a simple string from an object, which yeah, you can see like the module, Metro JuliaCon demo, you see the country. The first parameter is is a vector of city, so you see the city vector with the actual city objects. So Amsterdam 920, The Hague 565 population, and Eindhoven 246, ending with the area of the country. Okay, so we've now shown a little bit that we can support any kinds of complex structures, and we are also able to map actually to custom defined structs. I'd like now to move on also to maybe another bottleneck that you might experience if you have maybe problems that require a lot of data. So just to show that you can also run it on problems that maybe, for this example, I took in a vector of 1 gigabyte. And again, we do a simple operation. We just do a scalar vector multiplication. So the scalar being free, and this is in MATLAB notation just a linear range, going from 1 to 125 million, which totals up to 1 gigabyte of data. And then after the broadcast multiplication, you should end up with a vector that goes from 3 to 6 to 9, and so on. And yeah, so you see it's like a few seconds to transfer the data to Julia side, and then also transfer the data back. And then the first 10 values of the output of this particular function is just 3, 6, 9, 12. Okay, so now we've given you some toy examples, but the reason why you want to use such a package is actually also because you want to use the Julia ecosystem. So in this particular case, we show you a toy example created by the SciML ecosystem. Actually, it's a toy example for ordinary differential equations. In this particular case, they just do like a simple radioactive decay differential equation. I copied exactly the example, and sorry, it's example over here, and wrapped it into a function radio decay carbon-14. We see it's calling actually the ODE problem, which is the input to this differential equation interface. And as an output, we will see like a simple decay output. So let's now also try to replicate the toy example. So before we show you the picture, you already see that this is the output of this particular ODE interface, which some might recognize. And if we plot the actual solution, we get similar results as the one presented in the toy example. Okay, simple integration, what's that about? Issue, cannot find the function. Oh, that's right, it's not integrated yet. So let's now also do a live integration. So like you might know from using Julia regularly, you need to restart your process. And let's go out again. It can take a few seconds because it's also configuring the environment at the first time you run it, and then we see hello JuliaCon. So this was the demo. We'll continue with the presentation now.
So it's F5, I guess.
Shift F5 right there.
Fine. The bane of the demo.
Oh wait, are we still?
That's it. It's demo. Okay.
Demo.
Very briefly, because then there will be some time for questions. So I just want to briefly recap what we have seen so far. So essentially, I think I hope we convince you that we are heading toward a robust way to exchange the information between MATLAB and Julia. Our main objective was to be able to call essentially Julia code from MATLAB in the most painless way possible. And by doing that, we also, I hope that I convince you that we can mix and match these two languages better than what was done before. Although I mean this is not all positive. There's a lot of things to do. This package, this part of code was just created, so we really need a lot of testing. So if anybody of the audience is interested in testing this, please do it. We will explain how to do it. We really need to find bugs, essentially. Finally, there's another thing that is still in here, in the sense that we want to add more item to the an hypothetical roadmap, because we just solved the base problem, but we're pretty sure that there are a lot of more use cases that the community, the open source community, for example, can provide, and allows us to grow this project a bit better. So, in the cases anybody of you wants to contribute, essentially just to let you know that this project is one of the few key projects that was mentioned during the keynote, the introductory speech this morning. We are releasing everything in open source as of today, I guess. Yes? So feel free to go there, download it, try it, hack it. The more that you to try it, and the more that you give us feedback, the more that we are happy. So, questions?
Paolo and Joris, thanks a lot for the nice presentation. I think it would be really great if you say a few words about the underlying mechanism, how you're using the representation of MATLAB, that everything is a matrix, and you pass it like that into Julia, so you're saving of copying the data.
So the question is essentially how we perform the data marshalling on a high level, right? Okay, so all these high-level languages, such as Julia and MATLAB, essentially they have some kind of intermediate representation inside their core that allows us to describe these types dynamically. What we do when we perform, for example, taking what you said as an example, multidimensional matrix. So the multidimensional matrix has a very well-defined representation both in Julia and MATLAB. So what we do is we try to find a ways to copy the elements of each matrix only once or maybe twice, where the second time is essentially the transferring from the data from the MATLAB process to our process. So for now, the process is just a basic copy memory mechanism. But there are ways that we might use to reduce the number if you reuse the same data again. Because as things are now, if you perform the same operation on the same matrix, if you don't use particular shortcuts, so to speak, then you will copy the memory multiple times. But this is just, for now, this is just we haven't implemented it yet. But there's multiple ways that this can be achieved. Yes?
In the meantime, the next speaker can come up.
I have a follow-up question on the memory. It looks amazing, by the way.
Thanks.
I was reading it on GitHub. You make 2 copies. Once you send it to Julia, and once you get back. Sending it to Julia, I understand it's due to the copy on write behavior of MATLAB. Why do you need the second copy when you get it from Julia? Is it due to garbage collection?
Sorry, can you repeat the question, please?
So I understand why you make a copy when you go to go from MATLAB to Julia due
Yes.
to this infamous copy on write behavior in
Yeah.
MATLAB. On the way back, I would have presumed that you could just move the memory location. But I guess
Yes.
there's garbage collection in Julia that's behind the scene. Is
No,
that
it's
why?
in this case, it's not even. Is
I think in this stage, we really tried for the safe route and
Okay.
yes.
discard all these features. But in the future, like sharing of memory, we definitely will have to look into. But on the short term, it was not really easy to
Yeah. And also, so long story short, yes, we did it because it was the easiest solution, the most practical one. But there's also the process boundary that you need to cross when you do communication.
Have,
But we can,
Okay.
I can explain it later. No worry. I just don't want to go too much in
well, I
technical
was
details.
wondering if you had tried a shared memory mechanism via.
Can you speak up a bit?
I was wondering if you have tried a shared memory mechanism via memory mapping, which is a capability which exists both in MATLAB and Julia.
We haven't tried it yet.
Okay.
But this is something that we can definitely look into it.
Right. And then my actual question was if you also had, I noticed you were jumping between MATLAB, the MATLAB GUI, and Julia and VS Code. Have you tried running this via the MATLAB VS Code integration?
No, actually, that's a very good question. No, I haven't tried the MATLAB VS Code integration. I know that is recently, yes, indeed, it's improved quite a lot. So that's a good one. But I haven't no hand-on experience so far. Maybe, yeah, indeed, he has more experience on this, and it should work essentially. Fair enough.
With the package originally being called Bifrost, doesn't it make sense to support calling it from Julia as well, to have the bidirectional communication?
That's a very good point. Technically, yes, but I started with an idea. We started with an idea, and then essentially we decided, okay, let's slim down the context. Also because doing things in this way allows us to bypass a lot of technical problems.
Sure,
Because you
thanks.
don't have to think in terms of the other way around. I don't know if the other guy is popping up.
Wrap it up.
Any other questions, curiosities? Otherwise, thank you so much for the thanks. Thanks.
Expert is here. Yeah.
Thank you so much.
Charles, any Charles in the building? The speaker for the next session? Not yet. All right, then is William already here? Maybe. No, no. So I believe we don't have the speaker showing up here for this session. Then we go grab a coffee or something, and hopefully in 10 minutes we have William doing 8-bit development in 10 minutes or so. Apologies. Yeah, 2 more 10-minute talks. No, the speaker doesn't show.
Oh, okay. So I'm the next 11:10.
So you're William or?
Yeah. Bill Burdick.
Bill Burdick.
William is another name for Bill.
Oh yeah, now I see. Oh yeah, got it. Yes, perfect. So the speaker before you didn't show up, so I just sent everyone to a small coffee break.
Oh,
So you're
if I got here earlier, I could have had a longer talk.
Yeah, shit. We just but there's anyways nobody after you, so if the crowd loves it, then
Does anybody here like Commodore 64? No? Well, that's what my talk's on. So, using Julia for 8-bit programming. Do I need an HDMI port or do you have USB-C?
so let me just position this here. So there is an HDMI cable. Let's see, where was it? Okay, we have an HDMI cable here.
Ah, all right.
So
Here's my dock.
all right. Yep. There we go. Oh, he couldn't either. All right, then that's good. Hopefully we didn't lose the crowd now. That's okay. I'm curious about this one.
Is there a place I can plug in?
Right, let's see if the screens are, in case your laptop is warming up.
Yes. Tubes are warming. It just blinked, so did it show up on the screen?
Not yet. I don't know why this.
Oops. I'm showing two displays. My mouse is hitting another display, but it's not showing.
Yeah, no, not yet. I don't know what this laptop is about here. This is
It's somebody else's.
not showing? Okay. I'm going to try my other computer.
And otherwise, I might have another adapter, possibly.
No, it's not showing. It's showing a separate. Let me try my other machine. Takes a while to boot.
Yeah. That we have to type. You take a seat in front.
Expect some what?
Expect some Super Mario.
Haha. Oops. Okay. Hopefully something should happen on the screen.
Not seeing something yet.
Ah.
Deze.
No, it's like it's going to let me. Now is it showing?
Or is there another? Is HDMI? Deze laten we dus bij jullie ook. Ja.
Dat is min. Well, let's see. Maybe the display. Here. This says do not use. Oh, am I accidentally starting a game? Second. Did not mean to do that.
I think it's 4K.
It'll do.
So we'll just do 920.
Ooh. We've got a problem here. It's got sticking. Shoot. Yeah, I seriously need. Oh, it's like. No, I had to reboot it. Well, my laptop wouldn't work with the screen.
Yeah, maybe if you try 920.
Oh.
On your laptop is it you have a PowerPoint or PDF? Or?
No, I'm gonna do something live.
Okay, yeah. So just
And now I'm eating into my time already, I think.
we have nothing after this. So if people want to stay after, but
It's already 4 minutes. Oh
Yeah,
man,
yeah.
that's like half my time. I got here 4 minutes early. Sorry.
Have you tried unplugging the docking station power and plugging it back in?
It showed up on my laptop, but nothing happened on the screen.
The docking station has its own power.
The forum
Go
says
to the-
it should be unplugged and then it should work.
Okay, I'll take all the plugs out.
So take the plug out and wait until the signal is detected and plug it then back in.
Alright. Okay, make sure Bluetooth is turned on.
Yeah, we could try that if this doesn't work. Then we can try again with the laptop with your
I need to
laptop.
go to this properties from the screen.
Okay.
I think it's 4K. Display settings.
Okay, now that's not showing up.
So if this doesn't work, we can also try with this docked adapter for the HDMI with your laptop.
There we go.
Yeah,
Is
try
it-
choose. And try on 50.
50?
Yeah.
Anything? So
The
it's
laptop has USB-C, right? So maybe we can use this.
okay. Try it. Yeah.
Yeah. So Steam Deck has it directly.
Yeah. Yeah. So
Directly. So.
I've got to try another dock. Oh well, this one showed up.
We're seeing some stuff here.
Okay, great. Thank you. Okay, now I just have to get my.
Alright, so afterwards we have a break, so if everyone is okay, we can give him the full 10 minutes still. Is everyone good with that? Yeah. Alright, awesome, thank you.
Okay.
I guess you still need to get set up a little bit more.
What's that? Oh, yeah. I wasn't planning on doing this off my Steam Deck.
No worries.
Okay. So. Can
Now we see a white browser. Now we see settings. Yeah, if we can want, we can move this a bit maybe as well. There we go. There's no cables hanging.
Back to the audience when we do this.
All right. There it is.
No?
It's a different presentation.
Sorry.
No worries.
That was it up there.
I saw a retro talk.
Oh, it's on this. It's on my other display. That's how many tabs I have.
I can see. I can see. No shame in the tabs.
Okay, so.
All right, take it away, Bill Budrick.
Burdick.
Burdick.
Welcome to Retro 6502. So, how can Julia help with 6502 development? I mean, setting aside the idea of compiling to a 64K machine. But first, let me see if I can start up a terminal here. Sorry for the dishevelment here. Okay. I need to. There we go. Oh no. Hold on. Shoot. There we go. I didn't go through my ritual. Gives me a little time to first X here. This is when I was going to play the music to a Commodore 64 game called Comic Bakery, but I don't have time to do that right now. But it's by Press Play on Tape, covering Martin Galway's song. I'll put links in the YouTube if I can. Let's see. Okay, so I just loaded move.jas. That's the Julia assembly language. I'm going to assemble it, which also has some time to first hex. Okay. Oh, I haven't synchronized my changes. Darn it. Oh well, this isn't as nice as it could be because my laptop has the more recent code. But so you can see we've got this Commodore 64 screen running interactively. That's kind of a useless monitor there because you can't really track that with your eyes, but I'll get breakpoints in there at some point. And then we can see, let's see, characters on the screen. Over here you see that ASCII. Well, that's the screen code, the Commodore 64 screen code character. If I hit Control Q, I'm back in the Julia REPL because this is actually all inside of a terminal. Because there lately have been some developments to display and interact with real bitmaps images inside of terminals. So I thought it would be nice to just extend the Julia REPL this way. So I have to find my slides. Oh, I'm on a different, okay. There we go. That was the blinking lights. Okay, so we've got this ASM REPL. It extends a Julia REPL. It's screen-oriented like the Commodore 64, and it kind of looks like the Commodore 64. Supports different layouts. It uses a worker for assembly because I've got this pure Julia 6502 emulator, and I'm using eval a lot, and it scribbles into the Julia environment, and so you want to be able to throw that away. And right now there's not a good way to like reclaim resources for like identifiers that you've defined inside of Julia. So I use workers for that, so I can just kill the worker and restart a new one if I want to clean up the environment. And so I've got basic style load, save, run. So you can load, but it's for assembly code, but you can load an assembly program, make some changes, you can save it out, and it'll watch the file too, so you can just edit in, Emacs or VI or whatever. The assembler is there. One of the standard assemblers for 6502 is the TAS64. So this kind of, my assembler kind of conforms to a lot of its conventions, just kind of standard assembly stuff, but you'll see it uses 0x instead of $, because all the expressions in the assembly file are Julia. So like the TAS64 has a bunch of directives, and mine didn't need so many because Julia provides everything else. That you don't need an if directive if you can just stick Julia in there. These are the standard functions that come with TAS64. I defined a few others, but I also get every function defined in Julia if I want it. So here's an example data table. And my friend does Commodore 64 development a lot. He came out with a game he published in over COVID for the Commodore 64. I have it at home on a floppy. And so you can, so what this does is it defines a data table, and the Commodore 64 has 3 registers. They're 8 bits each. So managing data is hard in C64. So like if you want a table of addresses, you make 2 parallel arrays for the low bytes and the high bytes of the addresses, and then you index that with X, and then you load each, the high and low, into different registers. So that's what this does. And he was like, that's a error-prone process. How does your system handle that? So I did it in 2 lines with Julia, and then I added another line to align the code on the page boundaries, which was more logic. And then in my other changes, which I haven't synchronized, I just made it conditionally and aligned only if the data would cross the page boundary. So here we can see, here's the Julia code. It's just normal Julia code, and I'm just using eval a lot, and I'm using the parser to find the ends of the expressions. And then to use it, something you don't normally see in an assembly file is like multi-line parenthesized expressions like this. So you just, we've got Maluba and Fred data items, and I have the addresses right there in just a regular Julia array. And I pass that as an argument to the adder table macro. This is the movement program that I was just running on, that you saw on the screen, and thing back and forth, right? So the bold code there is in Julia. So I've got some fake routines there. So in order to do this, because I don't have a super high fidelity hardware emulator right now, so I can't do sound, and I can't do the I/O on chip like in the emulator. So I patch in fake routines there with the .fake directive, and that hooks up to a Julia function. So that way you can call in and out between Julia and the emulator. So you can prototype your 6502 code in Julia, and then like after it works and you've tested it, you can translate it into assembly, and then you can drive automated testing from Julia and verify the 6502 routines against your Julia functions if you want to, because you have full control over the emulator. And the way it does the fake is it starts them at 0 and it just gives them consecutive addresses, even though that consecutive addresses don't make sense in a 16-bit addressing system with 8-bit words. So you've got them like overlapping, but it's all fake. And so I just patched in scan key and get in to call the Julia routines there. And those are the real ROM addresses for 6502 routines there, but I'd have the ROM swapped out. So it does do the bank swapping, so I can actually use C64 ROM, but since I don't have a high fidelity emulator, I can't actually run the ROM code to scan the input because I'm not emulating the keyboard scan lines and stuff. Yeah, that's just the highlighted Julia code. That's pretty much what I have. Future directions, I do have a rewinder, so I can do like omniscient debugging, but I don't have like full hooks into that. But I do have like in another, with some disabled code, I have a slider where I can go back and forth in time and see hello world unwind, So, and what I'd like to do eventually is have, you can just create emulators. They're very lightweight on a machine this powerful, because it's 1 megahertz machine that we're emulating. So, what I'd like to do is do like probable futures, and so like a series of screens that go off into the future. And as you're like playing a game and you're debugging it, you can see what happens if someone were to, make the joystick go down instead of up. So you can see, it's kind of a little sci-fi, but I think it might be useful to be able to view into the future. Also, I like to make a test, like a full test harness for doing, testing, because currently people, when they develop on 6502, they write their test code that it runs inside the emulator, and they have to write it in assembly code. So That's it, I think. Oh, it's related work. There's some interesting, the Turbo Rascal syntax error project is interesting. It's a kind of a low-level Pascal. It generates 6502. The kick assembler is written in Java. Includes a high-ish level scripting language, and you can extend it with Java, but you have to like run it in Eclipse and write extensions and link them in and stuff. And then 64 TAS is the other kind of standard one. Shoot, and my QR codes are on my laptop, which wouldn't work. So.
Thank you.
Yeah. So that's my talk. Are there any questions or?
Very briefly, do one or two questions. Where's the microphone? Perfect. Some questions still? Yeah, over here.
How did you get into all this Commodore 64?
Oh, yeah, I was supposed to talk about that at the beginning. I started working on a game for Commodore 64, and I was like, this is so tedious. I need if I had Julia, so I'm like, what? And then I was thinking, what could I have done in the 80s if I had Julia resources available to work on the Commodore 64? So.
Is there still a market for Commodore 64 games?
Well, it depends on what you mean by market. There are people who are interested. Yeah, like my friend published a Commodore 64 game in 2021. So,
okay, cool.
Yeah, there are people out there, but you won't get rich unless you find a very rich person who wants to commission a project like a patron of the arts.
So I noticed that you didn't have all the directives. Does this run arbitrary Commodore 64 assembly?
No, I have my own assembly. So my own assembly language. So I didn't need all those directives because all that stuff's already in Julia. But so it wouldn't run a normal, like if I took assembly source code for like the TAS64, that wouldn't work because it's capable of doing everything and more that TAS64 can do, but the syntax is so wildly different, it just wouldn't work.
Okay, and then can you compile things? Like, can you run the assembly that you're creating on Commodore 64, or is it just like two separate?
No, you can if you're not like patching into fake Julia routines. If you're patching into fake Julia routines, then it has to run inside the Julia environment. So the model that I'm going for is like prototyping in Julia most of the stuff, and then gradually translating that into assembly, and then once that's done, being able to test that against, like keeping the Julia code around for test purposes so that you can verify the results. But then you'll have a binary, a portable Commodore 64 binary that'll run on my, on my Steam Deck in an emulator or whatever.
Thanks.
All right. One more question. Otherwise, okay, see one more last question, and then we can all go for a break.
So you got things running in the REPL. So have you managed to play Bad Apple in the Julia REPL yet?
I don't have enough support. I can't even do sprites right now. So my first goal is to be able to do VIC-20 games, which is a pretty low bar, but I'm not there yet. It's over my head at this point. But it does do real character graphics from the ROM. So.
Okay, thank you. You want to have one more question? Okay, very quick one.
Can you tell us a little bit more about bitmap support in the terminal? You mentioned
bitmap in the terminal?
Yeah. So how does that work, and how are you using it?
Okay, so I'm using an old standard called Sixel, which is from the late 70s, created by DEC for printers. And it has 6 pixel columns at a time that it can print. And this is a standard graphics capability that's been around for a while, and I think Xterm supports it even. Kitty does. Kitty's pretty advanced. That's what I was using, and KDE Console supports it. But there was somebody in 21 during COVID who didn't think that was enough and came up with an entirely new graphics protocol that also supports mouse input pixel by pixel. Right now you can do mouse input, I can currently support mouse input on just a character by character basis. So I can click the mouse on the screen to send input to it and click the mouse on the REPL to send input to the REPL. But what I'd like to do is take advantage of the new standards so that you could hover over a pixel and you could get information about the pixel that you're on. And once I have the omniscient debugging fully patched in, you'll be able to click on a pixel and get a program history of how that pixel, the lifetime of that pixel, and what changed it. What if you click on it, go to the code that set that pixel at that point in time. So.
I would like that. That sounds pretty cool. Okay, thank you.
Thanks. Thank you for letting me use your doc.
staat hij aan. Als ik ga staan en zo, dan zet jij me aan. Dit soort spreken, wijst dat zichzelf? Of moet
Ja, dat is gewoon over je oren heen zetten.
Oké, ja.
Spreekt voor zichzelf.
Oké. Staat hij zo aan?
Hij staat aan en als hij...
De eerste spreker staat er al. Excuse me?
I do have the talk online. Oh, thank you. I did put it online. I was just going to see if it was any different if it was on my laptop versus online.
No, you can just take over.
Okay.
Yeah. This is just on there too.
Okay.
I thought we nice, like an event.
Oh yeah, of course.
Nice welcome.
Yeah. No, that's good.
You can get yourself comfortable.
Cool. Thanks.
You have the luxury being the first speaker, right? So you have some time.
Yeah, I have some time.
There's not this pressure of. Well, we're doing the questions. Quickly mic up.
Yeah, exactly. Yeah, that one's a fun one.
Hey. Lauren will be presenting, right?
Yeah.
Is she already here?
She is.
Okay. Yeah.
She came upstairs to test, but it was booked, so she tested in some other room.
Okay. Yeah, I think it's one. So if you have to. In preparing, when you think about it, but now I'm here, I think maybe I should have like asked all the, like said to all the speakers, can you come here, like at before lunch or some other time, just to make sure everyone's here. No, I don't. So Lauren's here. I've seen Brad, Michael, Xander. I haven't seen Gerhard. Johannes I've seen. Megan. Yeah. Lauren. Yeah?
I don't remember seeing today.
Change the title of my slides. You don't have to change what I put. Right? Hi. I'm Keith.
I'm Lauren.
Hi, nice to meet you. Hmm? Hoe zeggen mensen dicht bij het midden komen zitten? Ja, ik zou dan ook. Deze mag nu. Ja, die kan nu weg. Oh, ik ga die gewoon bijhouden en ik weet niet. Ja, ik had hier al een kleine. Oh, je hebt een spreekbriefje. Oh, there's an AV guy.
Yeah, we're Michigan based. We're spreading out across the US, so yeah.
Hi everyone, welcome. Thank you very much for coming to the Industrial Julia Mini Symposium. I would like to ask that we put it on the slide before, but I would appreciate it if you tried to, it's not actually that bad, but if you try and keep everyone nice and close together, right, we're all having fun. This is supposed to be a nice interactive open session, so I mean, feel free not to stay away if you really want to, right? But and also we have to be a bit strict on the time, so I'm going to say very little more, but hand the floor to Michael, who has been so kind to fill in last minute for a late cancellation. Thank you very much, and the floor is yours.
Thanks. Hi everyone, I'm Michael Bologna. I'm a principal consultant at Great Lakes Consulting. We're a US-based consulting company that uses Julia primarily for web application development, for machine learning, scientific machine learning, and plenty of other fun. So let's talk about a fun problem. But now the year is 2015. We're working on a patient finance healthcare application that has already been in production, but in a smaller form, smaller scope of work. And so we're trying to expand the data sets, increase the amount of value we're getting from our data by doing filtering, aggregations, joining in memory for a finance team to try and understand their data better, trying to make good decisions. So these data sets are 100 plus columns. They're 30 to 50 dimensions, and then each of those dimensions, there's measures described in each of those. And so the data sets can be upwards of 10 gigabytes. And not only do we have just one data set in memory, but we're working with a bunch of hospital systems and different kinds of models. So now we're thinking about many of these data sets that can be up to 10 gigabytes. So along with this, we're trying to let users make changes to prices or rates or mixes. And effectively, we're going to keep increasing the capabilities of this. And it's based on customer requirements. We're trying to change quickly. So we need this low latency for lots of data and high capabilities. So what have we tried? We were originally in PL SQL, and this was fine for very fixed schemas and not much advanced capabilities, but we want to start increasing how fast we can iterate on our models, iterate on performance issues, and so we're scrapping the database. So let's try Java, Scala, Python, or R, and turns out that they're either slow or they're not very easy to use and to develop rapidly on. So introducing Julia. We found that Julia really is high performance. We prototyped something very quickly with the help of Julia Computing at the time. And ultimately, we got this into production. And we were over the moon, super excited. So this is our discovery of Julia in 2015. And so I want to talk today about the high-level architecture of this application. We're going to talk through some key packages that make this application come alive, as well as some effective Julia usage that helps with real-time applications. And then we're going to think through and reflect on how can we use Julia at your company, and finally wrap it up with some Q&A. So again, this is high-speed Julia. We're working with a national hospital system tracking 20 billion in annual revenue, and we're doing this real-time speed of thought scenario modeling. So we partnered with Julia Computing to produce the package JuliaDB. This was created in 2015. It eventually did become defunct in 2020, and so we did move to data frames at that point. But this produced the impressive real-time performance that we were hoping for. And this application is still in production today. So this might be one of the oldest Julia applications in existence, which is kind of fun to think about. And we've been continuing to enhance it over the years. So we're excited to reveal this more today. And to note, this application is not just, I'm running a Julia script here, a Julia script there. It's not just running stuff in the REPL. This is something that needs to be low latency, very available for users, and ready to iterate on data changes as quickly as possible. So here's a really high-level architecture overview, a little bit simplified. We're just using an HTTP server. Nothing fancy here. And I know that there's talks at previous JuliaCons and even this JuliaCon about the speed of HTTP, and I'm assuming at some point we'll get something better. But for now, this is fine for our use case. And when we query this backend service, we're getting to either read the data, maybe do some filtering and joining, or we're updating the data. And so we're making the appropriate calls to remote channels to do this kind of work. Or maybe we're changing the state of our application. We're saying, hey, we're locking this data down for this specific user. We're not letting anyone else use it. And generally just some other state management. So all of this is using dataframes.jl workers, and we've distributed them across upwards of 50 workers on production. And we're loading up data specific to whatever scenario we're working with. Maybe it's a budget for a very specific hospital system in Illinois, and we've loaded it up, and now we can run queries, updates against this data. And again, we're not using a database because we need fast performance that we're not able to get with the solutions available. So we're just reading and writing to file system. The only other thing I want to mention is we are not distributing the data across multiple workers in this scenario. We found that it was most helpful to stick exactly one data set on one worker at a time. That just seemed to be the best way to manage garbage collection. That happened to be one of the hardest problems for us moving from Julia 0.6 to 1.2 is garbage collection and compile time. And so sticking to one worker was a way that we were able to mitigate these kinds of issues back in the earlier days of Julia. So some key packages. Of course, we're using distributed. We're using a remote call fetch. And it's very easy to say, worker 8, I want to give you the Illinois data. Let me go ahead and load that up and do the appropriate queries. And of course, you can take advantage of threads on particular workers when that's available. And especially now in Julia 1.9 and above, we have access to better garbage collection that's multi-threaded. And I assume that over time we'll be able to use threads more often. And again, we're just doing the simple features of HTTP.jl. Because these queries take quite a long time, the overhead of using HTTP is very small relative to the kinds of database operations that we're doing. So again, we moved to data frames, and this is just as fast as the initial JuliaDB code. Not many people have probably used JuliaDB in this room, but it was very compiled down to the exact columns and data that was being used. And so that's why it was really fast. But when you start using 5 columns instead of 4 columns, now you have to compile a whole new method. So that was a unfortunate compile time problem that was solved by using data frames in this case. And of course, the more rows you have in data frames, the more often you're going to be able to take advantage of threads. And we added on the mempool functionality that was already in JuliaDB and some of the other highly distributed Julia packages to be able to do the out-of-core processing that is not available by default in dataframes.jl. And then for our file system I/O, we're using Parquet 2. And so the data compression and performant reads and writes were what we needed, but we had to limit it generally to using one thread at a time. So instead of using csv.jl, we were able to use Parquet, and that was faster generally than CSV reads and writes. So a JuliaDB dataset, which is like a serialized Julia file, was about 7 gigabytes, while the Parquet file is about 1 gigabyte. So now for some important tips on using Julia for a backend service. There's a lot of great features in data frames, and especially as we've gotten into the 1.0 era of dataframes.jl, it has been both stable and highly performant, which has been awesome. So if you don't normally think like a database, which most people in here probably don't unless you're a programmer, you think about big tables and you're saying, I want to select these columns and I want to do an operation on the entire thing as opposed to one particular row I want to do a for loop on. And generally thinking through code in this style has been highly effective, especially for memory usage. When we're talking about basically terabytes of memory allocated for these data sets, you're using way less memory allocations specifically the number of allocations used when you're thinking like a database, because a database, that's all it does, is it always thinks in big columns all the time. And so this is super important for especially this medium to large data modeling and analytics. So think through data in basically the data API.jl interface. So some of these methods are actually not in the interface, but they're still database-like operations. So instead of saying filter in a database, you're saying subset. Group by is normal. Transform is specific to Julia, and this is a great feature that you can say, oh, I want to add this column or combine these columns together to make a new one. And then, of course, the joins in place and out of place. So this has been effective not only for this application, but for multiple applications that we've been creating and maintaining for other users in the past few years. My second tip that's important is when you have lots and lots of requirements that keep piling up, you're going to need to continue to iterate on them quickly. And Julia, by far, from what we've found in our experience, is one of the best programming languages for prototyping. So continue to use the Julia REPL or use the VS Code extension, being able to run your code little bits here and there to test your code live against your data sets. And if you've never checked out Revise before, this is a very important package in the Julia ecosystem to be able to set up your code, make changes, and there's plenty of documentation and talks on how to use Revise nowadays, so those are easy to Google. And this was already talked about, I believe, by Sam yesterday at JuliaCon, but focusing on interface development is really important. We want to talk about verbs like create or run or something that really describes your data, like calculate variance or these words that make something click in your brain that say, oh, this is what I'm building, this is similar to the customer requirement, this is similar to what the user is actually doing. So with these tips in mind, this will really help you iterate on a brand new either greenfield project that you're writing in Julia, or it could be some existing code base you're translating to Julia, thinking through your code in verb form. One other really important thing to think about when you're working with Julia is, of course, the just-in-time compile. And when you're working with a web application, that is literally the antithesis of web application development, is you need that first query when the user runs that endpoint to be fast, and by default, that is not the case in Julia, because we need to compile this method, compile that method. So we need to think through critically, how are we going to get around this problem? Really, it's a help that we have very fast code, but we got to get around the compile time. So pre-compiled tools, that came out, I believe, last year. Looking through the documentation and talks on that is very important to set up your code base in a way that takes advantage of those tools. You can also create a sys image using package compiler. You can check out the documentation for that. That's where you're packaging up all your libraries, your packages together in one image, be able to load it much quicker. And generally, you can get compile time performance there. And another way is just creating a warm-up script. Go through all the endpoints that your users would normally use and just put in some real data. And now you've already taken away that problem of, hey, is this first query going to be fast or not? We know for sure it is because we've run it already. And then there's some smart architecture decisions you can make to keep workers warm in a sense. So maybe when you're not working with that many users, restrict your user set, your worker set that's being used, and you'll always have your compilation cache ready. Okay, optimizing memory usage is super critical, again, when you're using lots of memory. So I love this optimizing serial code article by Chris Rakakis. It's on book.sciml.ai, and that's been one of the most helpful tools that I show to developers or customers to say, hey, this is how you write really good serial code in Julia. And it kind of teaches you some computer science concepts too. So these are just a smattering of some ideas that are written out there. like avoiding cache misses and iterating along columns the way that memory is allocated. But ultimately, you're trying to avoid as many heap allocations as possible. There's allocations on the stack that are very cheap when you create and stop a call stack, but anything you're using with dynamic memory, meaning something you don't know the size of at compile time, those are the things you want to minimize. So either you can reuse the same variables or using fused broadcasts. Those are the things that you want to think about, trying not to copy your data everywhere when you're calculating and producing the output that you need for users. Using views is another great example. And this is a really simple example of type stability. It's kind of comical, but it's also critical to think about, can I have my Julia types as concrete as possible? So that way when I'm operating on large data sets, I'm able to be in a type stable mode where the compiler can do much better. So instead of a vector of any, this trivial example would be better to have a name tuple where you've got a string and a float as opposed to a collection of data that the compiler can't inference. So to recap, these tips are what we followed, these 5 tips, and that's gotten us to a place where this app is in production, steady now for 9 years, and we've been able to improve performance and stability, and we've moved, we're probably one of the few people that can say that we've migrated legacy Julia code to modern Julia code, but we've migrated from JuliaDB to data frames, and now we're set up for future cloud usage, getting to start using all the capabilities of that to increase performance even more. And I expect as future compilation and memory tooling is available in Julia, it'll get even easier to create really heavy data applications that are also performant and stable. So these are tips that have worked well for us, and they will continue to work well for other applications. But now it's your guys' turn. How will you use Julia? Will it be for engineering or for some science? Is there an application that makes sense for you? Are there day-to-day business operations and number crunching that you can do better in Julia? Is there a greenfield project that you're thinking of that you've been wanting to do? You can't find the application, the right architecture. Or maybe there's some data science that you've wanted to do and you're kind of tired of Python, or you think that there's probably a better way, probably more performance I can eke out. See, the sky's the limit with Julia because of how quick you can iterate on development, how quick you can prototype, and how high performance it is. It really is the best language in 2024 to be using for greenfield development because there's nothing else that you can grab all these different packages together and produce something that's never been done before, like what we did with this financial application in 2015. So just to give your appetite a little bit more to chew on, this is another business analytics case study, specifically from 2022. So there's a popular airline in the US, and they contracted us to make a dashboard application to aggregate and do some analytics on some flight schedule data. And so we started development, and it was just 8 weeks that it took to get actually to a place where we're in production, which was great because it was 3 times faster than they were expecting us to be done. And this is because Julia is fast to develop in. And the faster you are at Julia, we actually didn't even need all of our developers. There was 4 times less budget than what we were expecting, which is great, this was not something that was going to be possible in Python because it was just going to be slow. It was not going to be real time. It was not going to be something where you can see the analytics in just a couple seconds. So of course, what do you do with your remaining time? You just make it better. You just do something that's never been done before. So they were set up well for the next version. And if you're looking for what packages we're using and kind of how to do this yourself, maybe, we use DB interface to pull from the database. Of course, we're using dataframes.jl. And there's some nice plotting utilities. If you've never checked out the plotting libraries in Julia, Plotly.js is a great library for that. You can make things really interactive. You can download, and you can kind of crop and make edits to the view of the plot. We ended up using Stipple and Genie framework for this one, and that was really effective to be able to just wrap everything up all together. It was a nice, clean interface, and we just got to do everything that we needed to really in 8 weeks. And so this was successful, again, because prototyping was very simple in Julia, and it was high performance. I'm just going to give a smattering of a couple other industries that we've touched with differential equations, and these are some of the packages that we've used. But effectively, we have success stories of moving things from MATLAB to Julia, whether it's 1,000 lines or 10,000 lines or more of MATLAB, and computational fluid dynamics, thermodynamics, macroeconomics, pharmaceuticals. But really with Julia, the time is now to start developing. There's so much you can do to advance your business. So just take a step using Julia. Just start with your next greenfield project. Get ready to develop that back-end application that you've been wanting to do to create value. So we have a Julia Basics blog series on our website, and our website's got a QR code there, but that's what I want to talk to you about today, is getting ready to do Julia in 2024. And I'll take any questions.
So are there any questions? Very quick.
Yeah, so I was wondering, you started out in Julia 0.6, so even pre 1.0.
Yeah.
How did you distribute Julia, like an application back then? Was it like, and did that change over time? Did you choose a different way of distributing?
Yeah, there was, I think, 5 different iterations that we had of our architecture. It really does make a lot of sense at the end of the day to just keep all your data on one process when you have this much data. If you have less than terabytes of data, maybe you only have like 10 gigabytes of data in memory, maybe you can just stick to a couple worker processes instead of only using distributed. But yeah, our data size, it just made sense with garbage collection. And this was before threaded improvements to garbage collection too. So it really just made sense, separate Julia processes so the garbage collector can run as needed.
I'm also interested in how Julia was. So did you run it on the web, or did you have a distribution that you provide? Okay, so you ran it on the web. So it was running on a server.
It was on a server.
Yeah,
it was on a server. Yeah. We just started up Julia, in an infinitely running script. We're just continuing to run the HTTP server until we quit it.
Okay, clear.
Yeah.
Thanks. Yeah.
Yeah.
Any more questions from the audience?
Hey, thanks for the talk. Just quick questions. I was wondering of any consideration about the usage of Parquet as opposed to perhaps Arrow formats, and whether there were considerations on the I/O from not using an actual database and by potentially reading large chunks of data rather than being more granular. So I don't know if you could provide some clarity on there.
Yeah, sure thing. I believe when we did our performance testing, it just happened to be that Parquet was faster, single-threaded versus Arrow. I think Arrow might probably be faster when you have multiple threads, but we are kind of constrained to using one thread. And then as for splitting up the data into multiple chunks and loading, that's another thing that we had considered. That's actually really effective when you're using D tables, is kind of splitting everything into different chunks and pulling it all together. So in our use case, it just happened to be faster when we were prototyping to do it the way that we did. But your mileage may vary. Honestly, it could be better splitting things up.
Thank you.
Mm-hmm.
Okay, I think that's all the time we have for questions, but I'm guessing you'll be here for a while.
Yeah.
Right, I think it's Xander up next, right? Talking about PPTX. I'm going to use it. It's not a bug, it's a feature thing here. The screens at the outside are disabled, so to really encourage people to come to the middle. That's. But I'll hand the mic over now.
Yeah.
All right. Let me set this up. Yes, so I'm here today. Hello, I'm Xander de Vries. I'm here today to talk about our first, as ASML, our first open source contribution to the Julia ecosystem, which is a package to make PowerPoints. And honestly, it's mostly my pet project to learn to code in Julia a little bit. And then Matthijs's pet project to learn how the open sourcing works within ASML. So we work together on this. So I guess my first job is to kind of convince you that it's useful to use PowerPoint to present your data. So I did my best. I'm not being paid by PowerPoint to make a kind of comparison here, but I did my best, and whether it's fair, it's for you to judge, obviously. Right, so I came up with a few categories. So the first one is interactivity. So yeah, if you look at or these are kind of the things that I'm comparing to. So a notebook, Pluto or Jupyter. You can make a dashboard with Genie and also with Pluto. You can make a PowerPoint and you can make a PDF. These are all the categories that I came up with. Probably you can come up with some more, but okay, let's compare it on these platforms. So if you look at interactivity, then obviously the notebook is the pinnacle. You can add new Julia code, you can load different data sets and stuff like that. So it's very interactive. In a dashboard, you can not usually load new code, but you can actually insert new data, so it becomes at least somewhat interactive. In PowerPoint, you can put some animations, but basically all the plots that you put there are static, so you cannot really do that much with it. And a PDF is completely static. Then when we look at stability, I gave the notebook solution a minus, because I've noticed in demos and in presentations that, well, it's not always the most stable. It may depend also on whether you have internet connection available or whether your packages can properly precompile. If you distribute with a project and a manifest, you're somewhat stable, but even then I think it's like not as stable as just the more static solutions. And then with the dashboards, obviously you're more stable because you're hosting it somewhere, so usually that's okay. PowerPoint is very stable, obviously, and a PDF is also stable. Transferability, so how easy is it to pass it along in your organization? Well, with a notebook, it's somewhat difficult, right? You need to make sure that everyone has set up the Julia and its environment properly. With a dashboard, it's maybe easier if you host it somewhere. And with a PowerPoint and a PDF, it's very easy. And then, yeah, I came up with this term. I think it's a bit loaded, but it's like a composability. How easy is it to put like other stuff in your presentation or in what you want to present? Here you can also use PowerPoint to, for example, add a conclusion slide or something like that. Yeah, this is a category like that I just skip over. So basically, we found a use case for making a package that can make PowerPoints. So I looked into it a little bit. What is a PowerPoint? And I came to the surprising conclusion that a PowerPoint is just actually a zip file, which if you change the extension to zip and you unzip it, then you find out that it's like this just a folder of XMLs. And if you write the proper things to the XMLs, then the PowerPoint, and you zip it again and you rename it to PPTX, then it will just appear in your PowerPoint. So it's really as simple as that. So I thought I'd give a short demo about how the package works. It's very bare bones. So let me see. And I heard something yesterday about praying to the demo god, so I'm doing that right now. Let me see if I can pull up something here. Is this mic also? No, it's not connected. I cannot type and hold the microphone, so. Okay. This working now? Perfect, yeah. Thanks. Okay, so clean Julia REPL. Obviously, I already loaded PPTX, but I'll do it again. So here's using PPTX. Then you can make a simple presentation structure with like open a presentation. If I look at the keyword arguments, then I think they are empty, but I know if you look at the documentation, probably there should be like a doc string. Let's check. Presentation. Yeah, okay, so there's some documentation on how to do this. So let me add a title there. All right, so let's make a slide. There's also a slide object. I can also give that one a title. All right, and now basically all the shapes that you see in PowerPoint, they are like different objects. Maybe we can see if we go in PPTX what kind of shapes are supported. I see here picture, presentation, slide, table, text box, so probably I can make a text box. All right, it also has some placement parameters that I can set, so I can place it from the left to the right and I can resize it. So now what I do is I complete the object by pushing the text into the slide. Right, so now the slide will contain the text box and I push the slide into the presentation. And now I see here that the presentation contains 2 slides. And if I now want to write it out as a PowerPoint, I can do write, I think. See if that works. And it automatically pops up. So that's like something that you can disable, obviously, but it's like nice if you are like quickly iterating on where you should place your stuff. And this is, so here you see the text. So now I made my first PowerPoint here. So that's a quick demo. I mean, there's also stuff on the documentation and on the README about it. So if you're interested, you can take a look. It's not completely bug-free, but like one of the most obvious bugs I'll try to fix in the next days because I found that out by using it. So what are the features right now? So basically you can make slides, you can put a text box in there, a picture, you can turn a data frame into a table, but maybe nice to reuse the tables interface for that. I don't know if there's like tons of use cases for that, but could be interesting. And you can make links. I thought that was a nice thing to add so that you can somewhat make your PowerPoint a little bit more interactive by maybe having some kind of menu on the first slide where you can click and then make some kind of picture appear, so another slide appear basically by linking to the slide. Some features that I thought would be nice, so the auto placement and the layout for the pictures. So right now there's no way to lay out your pictures. So you'll just have to come up with something yourself. We can support more shapes maybe and reuse the tables interface. And I think this last one is already solved. So basically, so the way it works right now is that there's like a static template on which you add new shapes and new slides. But if you cache that in memory, then you can actually ship this as an application, right? And you don't have to package the template with it. So, but I think this was already resolved now in one of the latest pull requests. All right, so that's it. That's my last slide. Any questions?
Thank you, Sander. Is it possible to use templates when making a presentation?
Yes, you can actually use templates, I think. I don't know whether I can find that back, but yeah, you should be able to find that back in the README or the documentation. Yeah. Yeah.
Nice, thanks.
Is it possible to open an existing slideshow, an existing PowerPoint presentation with it and add a new slide using the Julia package?
Not yet, no. So I know that, I think that MATLAB can do this, or at least I heard people say that MATLAB can do this, but I really wonder how to build that in, since like basically what I get is just the error that the file is in use, so I cannot really write anything to it. But I suspect that PowerPoint uses, or a MATLAB uses some kind of copy-paste clipboard mechanism. I don't know if I could do that as well, but right now it's not possible, no.
One really quick question.
Okay, where do you use it most in your daily life? I could imagine like when there's always a standard report to do, something you have to script, but maybe not the very individual fancy teaching slides. Is it like this? So
yeah, so I think the PowerPoint is a common way for example, our customer support to generate indeed automated reports. And since it's like one of the things that they rely on most, it was also on my list to put there, all right, to make this kind of tooling. So it's indeed for making automated reports. Yeah.
Yeah. Thanks.
Yeah.
Okay, let's give another round of applause to Xander. And hand the floor to Tom, who was billed to do a presentation at the same, together with another colleague of ours, but he'll be doing it by himself because the other colleague couldn't make it. I'm going to talk about which packages you should definitely recommend to colleagues to make the newcomer experience better in Julia.
Or the presentation.
Yeah, the content's different to what it would have been as well. But, the floor's yours.
All right. So yeah, normally there would be two of us here. Now it's just me, Tom. My colleague Koen couldn't make it today, so I had to sort of pivot at the last moment, hence also the change of the content of the slides. So, since you're all here at JuliaCon, I guess the general vibe in the room is that we all think that Julia is great, but getting a project to actually use Julia, like convincing your colleagues, your managers, like, hey, we should really use Julia for this, it can be a bit difficult. It can be really get some hurdles there. And some of it is just, gut feeling, change is always a bit scary, but some of it is really like just some justified concerns. Because if you have to switch over to something else, well, there's some really valid concerns about, is it feasible to do the project, it doesn't cost more, and how maintainable, how this will in fact impact maintainability. These are all very valid concerns, and we have to address them if we want to go to them and say like, hey, use this new thing. And at CUX, we've seen this with customers, with internal projects, we've seen this again and again. And from our experience, we noticed that the same questions always keep popping up. And then you as the local Julia enthusiast who's saying like, hey, we really should use Julia for this, it's kind of up to you to come up with a good answer to all of these questions. Questions like, are there enough experienced developers? Because you might be here right now, but probably one developer is not enough to do the entire project. And also years down the line, let's say 7 years from now, who is going to maintain this thing? You might not be around anymore. Is it a fad? So many computer languages have come and gone. They pop up for a couple of years, are super popular, and then they get relegated to the dustbin of history. Same thing goes here. Is it a fad? You need to have an answer to that. Maturity of the ecosystem. Are we going to have to develop everything ourselves in-house? Or is there an ecosystem out there with packages that we can rely on? Lacking infrastructure. There's a whole bunch of CI/CD set up already for like Java, C++, Python, what have you. But quite often if you're the first guy saying like, hey, use Julia for this, none of this is around. So you need to also have an answer to that. And this last one, that's the one I'm sort of gonna address a little bit today, is people saying like, but it's kind of difficult to use Julia. If I want to use Python, I just download Conda, download PyCharm, and I'm good to go, and have a good development experience. So why does it seem a bit more difficult with Julia? Why does it seem to be that case? And if you ask me, I would say, because we're kind of lacking the tools to hide issues. If you catch me on a very cynical day, I will probably say something like, an IDE is just smoke and mirrors to hide problems with languages. So yeah, if you think about it, let's say you're going to write some C++ program. Nowadays, if you're working on Windows, just download Visual Studio and you're good to go. It can do everything for you. But if you ever were to sit down with just Notepad and a command line terminal with a compiler, writing anything that's non-trivial, it's gonna be a pain. You will never be able to figure this out. Okay, what compiler flags do I need to pass along to link to this DLL? It's a nightmare, basically. But then you have an IDE that says like, oh, no problem, I will take care of all of this for you, and you have a great experience. So yeah, Julia is kind of playing catch up to the other ones there. Like we have all these great IDEs, PyCharm, IntelliJ, Visual Studio, but these are for languages that have been around for decades longer than Julia. They all know, these are sort of the issues that we have to sort of solve in our IDE environment. But with Julia, we're just only sort of getting started with that. But I would say there's already more out there than you might think. When I started talking to some other Julians, I started noticing like, all these packages that I think are sort of essential to have a good developer experience in Julia, they're not using them. They don't know them. So I'm going to highlight a few of those, and then maybe you come away with some ideas here today. maybe for yourself, but maybe also for this colleague who's saying like, I'm having a bit of a difficult time getting started. Then you can say like, hey, here's a few packages that might help you out. The first package I'm going to talk about today is the minus first package I'm going to talk about today. Minus because it's not a package at all. It's VS Code. So if you haven't been using VS Code, it's, if I'm being very cynical here today, it's just a fancy text editor. But with some extensions, there's a really good Julia extension there, it sort of forms the basis for what you would call an IDE. So there's a bunch of them out there. It does some basic syntax checking, which is nice. Some code formatting. You have a built-in REPL. Can do some simple refactoring. That's one of the things I would say, like, yeah, some improvement can be done there. The refactoring, if you compare the one in VS Code with one in PyCharm, they're light years ahead of us. That could use some work, I would say. But it's already a big improvement from just, typing some Julia by hand. Also interesting to note, some of the packages that I would think are really useful for development, they're already sort of baked into the Julia extension there. So there might be a few of them around that you have been using without even realizing it. The second package I'm going to talk about today is the minus epsilon package I'm going to talk about today. Why minus epsilon? Because it's still not a package, but we're one step beyond -1. And so we're not yet at 0 here. So the startup.jl, it's a startup script for your Julia. It's kind of like your bash RC, but then for Julia. So every time when you start Julia, it will execute this script. And it can be pretty much anything. I hope that's a bit visible. It's not too important what it exactly says here. This is just a startup.jl I took from a colleague. But you can do anything there. You can load packages, make sure that certain packages are installed. You can set environment variables. For example, with my startup.jl, if I spin up a virtual machine, I can just drop it in there and it will install all the packages I would like to use immediately. But you can do basically whatever you want in that. If you don't know, it's in your .julia folder. You can just, there might be a folder there, config. If it's not there, you can just make it. For some reason, they don't always have this by default there. And if you just drop a file called startup.jl there, that's the thing it will just execute. Could be very useful. Also interesting to note, there is a command line flag for your Julia command that can turn this off. So if you're just doing some batch processing, you can just easily say like, okay, startup equal to off, and it will not launch this. Okay, the first package, now the first real package for today, OMA REPL. So let me demonstrate this. So I have here a Julia terminal. Hope that's big enough. You can see here up at top, I started it with startup file equal no, because this OMA REPL stuff, it's in my startup file because I use it all the time. But then I can't really show you what the contrast is. I have here my Julia terminal. I can do things like usual. And I can start defining a function. No, I did not type it correctly. Function, f of x. And I say x is a number. And then we're going to do something silly. Just take the exponential of 5 times x plus 8. Doesn't really matter what I'm doing here. I'm just kind of making a point at. It's all white. The braces, which one matches up with which one? I have to kind of stare at it. It works, sure, but it's a bit of a pain. So now I'm going to load in OMA REPL. And if I now want to do something similar, things are lighting up. Much easier to read. Oh, but I need to type this correctly. Much easier to read. And also, if I then were to do something similar, that's 5 times x plus 8 minus 9. You see the braces, they're colored with different colors. So they indicate clearly, oh, this brace matches this brace. And if I put my cursor next to one of them, this might be a bit hard to see, but there's like a really tiny line underneath the brace that's next to my cursor. And there's a one also on the other side, the one that matches it. Makes it a lot easier to just read what you're typing. Okay, back to the slides. So OMA REPL is just basically a bunch of REPL enhancements. I showed off the syntax highlighting. There's the bracket improvements. Something I didn't really show here, there's also a really nice fuzzy search. You know that in your REPL, if you tap your arrow key, you go up, 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 up through your command history. But then you're thinking, oh, wait, I had this command that I entered 5 hours ago. What was it again? I need it again. If you hit Ctrl-R, it's just some hotkey combination, you enter into this fuzzy search, you can start typing things, and it does sort of a fuzzy search of your history. Could be very useful to find these things again. There's also a bunch of customizations you can do here. Might be something neat to put into your startup.jl. If you say like, oh, the standard REPL, I don't really like it, I want to change something there, you can put it over there. So OMA REPL, real big recommendation. Second one, revise. Somebody already mentioned revise here today. Definitely going to second that. You really, really need revise. Why is that? So let's say I have some Julia package here. It just doesn't really matter what it says here, just some things. And I'm going to start using it. First, I have to make sure that my environment is correct. And then I can do using my package. Okay, nothing too spectacular here. I'm going to call the greet function. Okay, I'm going to say hello to all of you. So hello, JuliaCon. But now I want to put something else here. Let's say I'm not just really enthusiastic. I'm really, really enthusiastic about saying hello to JuliaCon. So I'm going to get some more exclamation marks here. Oh no, it's still the same. And now I'm kind of stuck here. I kind of have to just close my REPL, start it up again, because otherwise it will just keep doing the same thing. That's not great for development, because we want people to write packages. And if you run into this stumbling block, then people say, writing something in a package is a pain. I'm just going to put everything on the REPL. Once I'm done, I copy it over, blah, blah, blah. No, that's not a good way of working. So let's not do that. And I'm going to get rid of that REPL, because I'm no longer going to need it. Because now I can just use the built-in REPL from VS Code, because this one will use my startup script, which contains revise. I have like this neat info messages there saying like, hey, I'm loading all these packages. So now I can do the thing I just did before. Oh yeah, also note VS Code is very helpful, already dropping you in the correct environment because it's recognized, hey, I'm in a Julia environment here. So I can just type using my package. Give it a second to load. My package.greet. Okay, but we're not surprised by this because, yeah, okay, I started a new REPL, so of course it's using a new version of the code. But now I can go here and be a little bit less enthusiastic again. And there we go. Now we have the updated code. So you notice there was like a slight delay. That's just revise noticing like, hey, something changed. I'm going to recompile this for you. Here's the updated version. Do note there's a few limitations here. So with functions, no problem at all. But now I have here the struct definition. If I were to change this to int64, then revise will notice like, hey, something changed, but he will immediately shout at me saying like, hey, what you did, I can't do that. So he immediately says here, invalid redefinition of this type. So he's telling you like, hey, can you maybe fix this error and then try again? So let's do that. So go back to float64, and then it's just a really easy revise dot retry, yeah. And then, okay, it's not really visible, yeah. Usually I'm not using the light theme, but yeah, this shows up better on the screens. This one was sort of yellowish, now it's green again, so everything is good again. Okay. Back to the slides. So yeah, revise, it automatically reloads code. I would say this sort of enables package-centric development, because without it, it's really a pain. It's going to take way too long, and we don't want to sit around waiting to reload our REPLs all the time. Also enables test-driven development, because now you can sort of experiment on your REPL. Oh, it's not quite doing what I wanted to. Change it a bit. Not quite. Change it a bit. Okay, now it's there. It really, really smooths out your development curve, I would say. Few caveats here. Doesn't work for a few things. Yesterday, there were some rumors swirling about people saying like, no, you can make it work. Other people saying, nah, I don't think you can do this. So maybe this will change in the future. Well, let's see. Okay. So the next two packages, the first one you already see here, retest, they're going to be test-focused. So I'm going to switch back to the code and take a look at some tests there. So running tests in Julia, very easy. I can just go to the package manager, type test, then give it a second while it runs all the tests. There we go. Okay, so we see, okay, a whole bunch of tests passed, a few failed, but the main thing here is that, oh, there seem to be some problems with the G function. But if I now change the G function and run my tests again, I can only type test and kind of stuck there. I have to run all the F tests too, even though I didn't change F at all. That's again, it's sort of a slowdown, delay in your development process. Now it's not too bad, but what if these tests for F were like really, really slow, or I had way, way, way more tests? You don't want to sit around and wait for that. I'm only changing G. So how do I do that? Well, that's where this retest package comes in. It's actually only a small change with respect to the usual way of testing. So with the usual way of testing, you just have the run test.jl file, and you just run that, and it contains all the tests you need. But now what you do is you actually wrap all your tests in this module, and the convention, well, sort of the standard there is to just say the name of your package with then the suffix tests, then also in a file with the same name. And then instead of doing using test, it's using retest, and that's basically it. If you just do that, you're using retest. So what I can do now is I can say, I can include this file. Oh wait, no I can't. So there's a really good reason why I cannot do this. I have here retest, I have here CSV. These are my test dependencies. I do not have them in my normal package. Why would I? For example, it might be that my package has nothing to do with using CSVs at all, but I might have some data there that I want to run my package. Same thing with retest. You do not read retest for running your package, so you don't need it. So how do you handle that? Well, yeah, what you usually do is you just have this project.toml here. You specify your test dependencies. But how do you end up in an environment where you can actually run your code and at the same time also have these test dependencies available? And that's where the second test-based package comes in. It's called testenv. And it's a really nice function just here, testenv activate. And what it does, it drops me into a temporary environment. You can recognize this temporary environment by this sort of JL underscore and then some nonsense prefix. If you don't know about temporary environments, check out the documentation for them. I will use them quite often. They're really, really useful. And you can see that I have a few packages installed here. So CSV and retest, these are just my test dependencies. And then my own package is installed as this sort of, reference to a local path. Also, if you don't know about that, with the Julia package manager, you can just install Julia packages that are only existing on your local file system. Just do add the path on your local file system, and you have it. So now I am actually in an environment that I can actually start using all my test dependencies. I could do the include again, but actually retest is something a bit more elegant for that. I can just do retest.load, and then the name of my package. Oh, yeah, I have to do using retest first, of course. And also using my package. And then it immediately knows, oh, because I'm following this convention, it knows where this module is located. If the REPL wants to respond, yeah. So then I have now this my package tests module available. Actually, it's also really neat that I have this as a module, because now, okay, all the variables that are defined, all the variables that are defined in here, which I might use for doing tests, I have access to them on my REPL. Otherwise, it's sort of locked away in some script, but now because it's a module, I can just load it in without executing everything that's in there. If this was just a script, yeah, I would have to include it, but then including it would also execute everything, which you do not want. Oh. And now there is this really handy function here called run tests. So there's a run test function. If I just call this without any arguments, it runs all the tests. But now I want to run only the tests that are relevant for G. And this is sort of my particular flavor of doing things. You can pass in a string here. This string will filter the test sets that you have defined, and it will filter it on the names of your test sets. And I personally like to sort of make this hierarchy in my name of my test sets. So I have my test set G, which contains this test set G dash something something. I like to do this sort of dashes to make this sort of hierarchy in my test sets. And then it will filter on like all the test sets that start with G dash. I can actually also say like, oh, but actually only the tests that are from the CSV are failing. So I can put in here G dash CSV. And as you can see, now it only ran the tests that start with G dash CSV. So some very, very simple string matching. If you want to do something more fancy, you can actually put in a regex there, and it will then use the regex to filter all the test set names. So this really speeds up your development process, because now you can just run only the tests that are relevant to the code you're changing. And once you're done, if you really want to be sure, okay, run them all again. Okay, back to the slides. So retest, testing framework, only a small change with respect to test. It's really easy to filter tests. Something that I didn't really show here is that it also allows you to run all your tests in parallel. So this is a bit of a bigger change with respect to test. Retest really enforces that all your test sets are independent of each other. If you define a variable in one of them and you try to use it in the other one, it will say like, no, you can't do that. And yeah, this is exactly for this reason. You can just use distributed, run everything parallel. Again, you gain some speed there. Testenv, yeah, I showed this one. You have this kind of problem with test dependencies because there's no sort of like merge environments function. And this will then create this temporary environment with your package and your test dependencies in them. Okay, so I've shown you some of my favorites here today, but we're running out of time, so I kind of have to stop here. I have a bunch more written here down. I also have a bunch more to talk about if you ask me later. But do you have any favorites? Please share them, because we can only learn from each other in this way. And also, what's your experience in trying to convince your colleagues and your managers to start using Julia? Especially if you think back to those questions I have from before. There's probably some really good answers to all those questions, but you need to share it with each other, then we can learn. And also, if you need any help, please reach out. We're here with the whole community. Some of us have successfully introduced Julia in projects. So yeah, ask around. To us personally, you can say like, hey, I need some help here because these and these reasons are a bit difficult here. But also on a professional level, hey, there's these companies who are actually using Julia. You can reach out. But of course, the main thing is here, you're not alone. Reach out, we have a great community. So yeah, let's help each other make Julia happen.
Thank you. So I think Tom made it clear, he doesn't want questions, he wants suggestions, right?
Yeah.
Any suggestions?
But questions are also good.
Okay.
Yeah, I don't know if you use it, but for a debugger, do you ever use a debugger?
Yeah, so that's the infamous debug question. So personally, I've never really used the Julia debugger because yeah, back when I started using Julia, it really wasn't good. Nowadays, I've heard it's much better, but I've really noticed from just the way I write Julia code, I don't really use it that often. But I do like Infiltrator. I did use Infiltrator maybe like 2 or 3 times in the past 2 years or something like that. And I've used a debugger never.
Okay.
So
yeah,
don't really use it that much.
I recently started with Infiltrator. And there's also some great packages that help you make documentation.
Yes, Documenter, use those.
Yeah, exactly. Yeah, that's also a really good one. Yeah. Okay, thanks.
Oh, right behind you.
Hi, so I have 2 questions. The first one is like, if I'm working on a team, I like to define within a team a format on how we develop code. So first question is, how would you do formatting and define something around that?
Yeah, so for formatting with Julia, there is a sort of standard Julia formatter, and it has a bunch of settings, and these settings you can save them into like something like .julia formatter file or something like that. So you can just agree on, like, because that's also a whole discussion in and of itself, what's the exact formatting you're going to use in your team. I've been in discussions that went on for weeks about this over a year in some of my projects. So, but as soon as you sort of settle on, okay, this is how we're going to format our code, you can sort of just drop in this file, then the formatter will pick up on this file, and then, yeah, you can sort of either, okay, you can say run it manually, but there's also things that you can do with like Git hooks to make sure that it runs every time before you commit. So there's options there, yeah.
Okay, nice. And the second question is, in Python, I would use something like Tox to run it on different Python versions. Is there like an equivalent in Julia?
I don't know exactly by heart. So what I do know is that with GitHub Actions, it's actually really easy to run your GitHub Actions on many, many Julia versions. But to run it locally, I don't really know. You could always just use Julia up to manage some number of different amount of Julia versions installed locally. But of course, I can kind of understand that, yeah, it's not the nicest way of doing things. But I haven't really run into the use case yet myself that I really had to check multiple Julia versions.
All right, cheers.
I think we might have time for one last question while you set up and Tom hands you the mic. One last question for Tom? No? Okay, well then another round of applause, I guess. Our next speaker is Gerhard, talking about, from heart, something about autonomous driving. Sounds really interesting. Tom, do you have the mic? Yeah, but he's right here. Where did you? Dat is gewoon hem kunnen geven. Oh, oké. Ja, zal er gewoon 2 moeten hebben.
Thank you.
Okay, the floor is yours.
Thank you. So hello, my name is Gerhard Dorn. I'm senior scientist at Virtual Vehicle, which is a research company in Austria dealing a lot with mobility, rail, and also autonomous driving. And I work in a project called AI for CSM. It's a European project, and we are working on a prototype, a robotaxi. And this is the car. This is our Ford Mondeo, which has the possibility to drive it by wire, so we can really do autonomous driving. And I work in the perception task. And what we have on top is a LiDAR sensor, which is a very cool sensor to get data about your environment, and I will show you how that works and what the challenge, for me at least, is to process all this data in real time in the car. And the connection is I'm using Julia for that. When I started at the company, they all used, I don't know, C++ and other directly CUDA implementation, and I just didn't want to use that, and they were not so approached or not so well established. So I had the chance just to work in Julia, and that's a bit my story, how I integrated that with the other colleagues, and yeah. And we just use a normal PC, so it's not embedded at the moment. This is also maybe interesting, but yeah. So this is a common LiDAR sensor. This is the OS2 Auster, which gives you 2.6 million 3D points per second, and we want to process that in real time. So it's really amazing what this sensor can do. It also gives you the reflection, so the intensity. You already can read the lane markings and everything. You see the signs, so you can also recognize graffiti on a wall. It's a really very powerful sensor, and I would say still expensive, but in the advantage of laser technology, I think, and also semiconductor processing, I think it will go down by some factors, and then it would be very interesting to have them in cars or as roadside units at streets. And so the challenge is to process this 2.6 million data points, and what we also do is we have a digital twin in Unreal Engine. There is a driving simulator called Kala, which is basically open source. This is like the car which we simulate. Then you see the 3D point cloud simulated in this simulation tool. Then on the right-hand side is one thing which I'm working on, an occupancy grid, which tells you where's free space and where is obstacles, and there was the intelligence. That's another video where we overtake and simulate overtake maneuver of a bicycle. So on the left-hand side, there's the intelligence module, which has a state machine and which is handling, can I take over, does path planning, all that stuff. I'm more interested in the right upper image, which is a semantic segmentation. So I get the slider points, and I want to classify, is the slider point a ground point or is it a wall? So basically ground segmentation. And I would do that with machine learning, with Julia, in the car, in real time, on a GPU. And on the right-hand side and below, you see the occupancy grid. So I use the data to get just a map where's free space and where's a wall. And these are the two challenges I have in perception. So the left image again is, I have 5 classes. So I also want to detect objects, which is not working that well, as you can see from the left image. And the ground is a mixture of street and terrain, which is basically the same in this simulator because everything is flat and you don't have really features to discriminate between them. But yeah, that's okay. So this is the challenge. I also have some slide about what the occupancy grid is, if you're interested in it. I just have to look at the time. So if you have a car and it has LiDAR points and you really get the 3D distance of this LiDAR point, and then I can say, okay, if I hit a cell, I say it's occupied. And all the other cells which I just passed through are free. This is blue. And the interesting thing is, what if I move further and do another LiDAR measurement? And I have again points. And then what can happen? Okay, some cells can be passed through which were obstacle before. So there are some cells which I gave the color blue and red. Some cells are now red which have been free before, which is this one. So maybe there's an object which is moving here. And so you can take this information to make also estimations about dynamics. And so this is t plus 1. And you see in the right-left corner, there is maybe an obstacle which came closer, because first it really passed through the cell and then it came closer. And yeah, what you can infer, maybe there is a wall, maybe this is a new object which was not here before, maybe this is a car moving away, and maybe this is a car moving beyond you. So this is the the data structure, also the idea to work with time steps, maybe do a convolution also over time to get these features and to infer on where objects moving. So this is the occupancy grid, which is basically fill in 3D points into a grid and then also check which cells did you pass using Brazenham algorithm and using some probability theory. So this is not so involved. And yeah, this could be a logic. 2 times 3 is 3, and 3 and then occupied. Okay, something is moving in or something is moving out. This is just a very basic heuristics how you could describe use this. And how do I do the semantic segmentation? So this is a 3D point cloud, and on top you see a spherical projection. So I have I use at the x-axis the angle around, so it's a 360-degree view, and I have some vertical angle, and I just map each point into a spherical angle. So this is, then you get a 2D picture, and this is what I get, for example, from Carla. You see this is the 360 degree. This is in front. Here you can see the bike in front, and this is just the vertical angle. And you get also different properties which you can calculate. So this is basically what is the angle change if you look up and down, what is the angle change if you look left and right, and you can use this as inputs for a machine learning network, which I use. I use Flux with UNet. So UNet is basically a classical image segmentation program, which for me it was easy to implement. So you have to do some convolution layer, you have to do some skip connection. So this is basically, I do some convolutions, and then I copy this array to the left-hand side to reconstruct the original one. And here I go down, go down, go down. Here I define features. I go up, up, up again, and I want to, I say here, maybe I have 10 features, the 10 classes, and I want to say which pixels belong to those 10 classes, and that's why I have the skip connections where I can reconstruct in the full image space. So this is a standard algorithm. There are better algorithms, but what's the challenge for autonomous driving is you want to have not the best in precision, but a real-time capable algorithm. So something simple which is good enough. Okay, and here's the strategy. I hope put everything together. So it was quite nice to start prototyping in Julia. So this is, and okay, this is not a pipeline. So in the car we have, I said drive-by-wire, so we can control the steering angle, we can control the acceleration, and this basically works over a CAN bus, and you have to do some sensor and actuator control, and we use there is a classical program called ROS, Robot Operating System, and then there is an alternative for this, which is RT-Maps, which is real-time multi-sensor application, something like that. We use that because it's rather simple. You can have blocks. This is the where's the mouse? This is the LiDAR input. This are 2 GPS inputs, and the important thing here I have a Python bridge, so I don't have to actually use C++, and here is Julia inside. So this is the maybe weird way how I implement Julia in the car, because this setup was already there, and my colleagues wanted to work with RT-Maps, and then okay, there is a Python bridge. Okay, I integrate Julia with JuliaCon, and okay, I work on a GPU inside, and it works. So this is cool, and yeah. And so I was experienced with the other package. What was it called? So there's Python call and PyCall, and it's not Julia call, but Julia. Those are the older versions, and the new ones are a bit more stable, I would say, and yeah, it works. There's some things if you want to do parallel computing, which are maybe a bit tricky. So how fast is it? This is just the benchmarks from the semantic segmentation in the computer, which we will use in the car, and they are still too slow, so about 250 milliseconds, and it should be below 100 milliseconds. And the occupancy grid stuff is below 150 milliseconds and should also be faster. And if I run everything together and measure the time, it's about 1 second, and this is factored 10 times too slow. But I already had some mentoring session with Julian, who showed me how to debug the GPU. There's CUDA.profile, and you can watch how many time do you lose for which step, and maybe there is also a bug. And the problem, he said, is if you do too many allocations, it costs you time. So this is the next step for me. Also learning a lot here at JuliaCon how to improve my code. So what I did so far is I prototyped, I integrated, and now I make it fast. this is the strategy. Yeah, how to make it fast. I work at the moment at 10 Hertz with the full resolution of the sensor, but I can just delete points. I don't need all the points. I don't need points which are behind of me. They're not so interesting. And I wanted to show you how it looks like at the moment. 1 minute, yeah. This is, where's the car? There's the car. So this is a real-time measurement somewhere in Graz in Austria. The car is moving, you see the point clouds. Here you can see also the reflection, which I have to show that, which is super cool, so you can get an impression of the sensor. And you see quite a lot. You can see the line markings, you can see the zebra crossings. This is just because they reflect more, and yeah, the rotation doesn't work that well. And this is the occupancy grid, which I need to improve from a velocity perspective, but you can see the free space and the occupied space. And yeah, basically that's what I wanted to show you. If you have any question, just contact me. And if, yeah, thank you.
Thank you. We do have a small break planned now, and I think you did fill the time, so maybe we should use the break for questions for Gerard as well, and then reconvene here at 10 past, right? 20 past for Janus's talk. Okay. See you then. That was
dat is een van die dingen waarvan mensen een beetje vergeten van. Dat ze zeggen van, oh, maar Julia is lastig vanwege dit. Dus oké, maar dat is gewoon hoe dat computertalen in elkaar zitten. Dat zijn gewoon een heel veel tools bij andere talen die dat allemaal makkelijk maken. Bij Julia, eigenlijk heb je bij Julia al een heel fantastisch voordeel vanwege die geweldige package management. Gelijk tegenover Python, als je daar zit met pip, en dan is het van, oké, maar Julia moet uitleggen, en dan hier is het code power.
So this is yeah, but it's kind of making it easy for me not to be in that mode.
En ook gewoon soms voor soft keyboard. Je dat echt gewoon zo van, probeer de swipes weer zo, en dat je gewoon, oh, dit is hier gewoon.
Ik heb een paar jaar terug de hele tijd dingen gehad. Bijvoorbeeld de volgende, wat ik daar eerst pandas, dan matplotlib, dan Seaborn bijvoorbeeld. Dat ging
is heel slecht.
Maar eerst Seaborn, dan de rest? Nee, nee, dat ging wel.
Ik hoor dat je precies van België bent.
Ja, when you're speaking, I speak at the same time. Yeah.
Your name,
why
not your name, the name your talk changed, right?
And look at
copy a template to best.
Ja, dus ik doe twee dingen. Ik heb een poster en een spec.
Wow. You like write the package every day, right?
Maar even voor
Unless he's releasing a YouTube.
ja, dit is based on what we make.
Okay.
Ja, ook sommige dingen. In Vesticon, yes.
Oh, Vesticon, that's great.
Ik heb dan wel op de naam dat ik een probleem kan vertalen.
Uiteindelijk ook, ja, waarschijnlijk een beetje de insteek van het systeem dat geld opbrengt. En dan is het inderdaad iets minder headache om te zeggen van, je daar in Python.
Maar bij zo rustig aan bouwen, zo zijn zo software service platforms.
And he's rated the US. Are you from the US?
Yeah.
But he's rated every state flag.
Okay, I've seen
And then one big cares for the
Does he have his funny
and we did have some
little
categories of F because most of them were F.
Does he do like the little like
En omdat
cartoon
het ja, docker-containers zijn, want dat is gewoon het ding dat als je Julia moet gaan deployen, dan veel klanten die zeggen dan, oh, maar daar hebben we niks voor voorzien. En dat is gelijk docker. Hier is een docker-container, whatever, dat draait overal gewoon.
Give me your top reasons.
I think the reasons I remember the most is like the optimization.
Oh, that's right.
Okay, so this break has been really nice and exactly why I was keen to have a break in our symposium. But we can get back. Also, the people at the end, this is not a bug, it's a feature. We want everyone to be nice and close together, close to the speaker. Gezellig, as they say in Dutch.
Perhaps it's going to really bad and people want to...
Your speech is going to be really bad.
Yeah, perhaps people want to
does anyone want to take over from this guy?
It's going to be okay.
No, I saw your talk yesterday, you're going to be fine.
Okay.
So the floor is to Janis, who'll be talking about Peace Founder.
Yeah, thank you for introducing. And I'm Janis Erdmanis, and today I will be presenting the Peace Founder project. It's an e-voting system. I present it in a context of full stack development in Julia. To understand what the stack solves and what it involves, let's understand the problem, the e-voting problem. Securing e-voting systems essentially means to defend against three main threats. Surveillance, surveillance knowing how voters cast their votes can influence how they their choices their choices due to coercion and bribery. There is a deception. Election authorities can secretly manipulate election results, or there is could be adversary which erodes the trust about the election results as attack vector deception. Also, there is possibility that voting devices themselves lie to the voters how they could cast the vote. And lastly, there is a sabotage, less talked about. It's disrupting the voting process itself, preventing the result announcements. These threats are understood in the literature, and there are certain properties which e-voting systems need to have. To combat surveillance, we need two properties. The first is anonymity of the votes. So the published votes cannot be linked to the individual voters. And we also need receipt-freeness, which means that voters cannot prove to the third party how they cast their vote. And this eliminates coercion and bribery. The second one is to combat deception. It's necessary to understand very well that we need end-to-end verifiability. This means that even if all authorities involved in the process, election authorities, are corrupt, they wouldn't be able to affect the final election result without being detected in the final evidence. There is also important necessity eligibility verifiability, so that the votes which come inside, the votes which are sent in are checked that they are signed by eligible voters, so that it prevents stuffing by election authorities. To prevent sabotage, we need to use robust systems that ensure some accountability measures in place, so that whatever happens, which is a bit ambiguous, the election result can be published. We also need availability, some tools to define availability. So if we have a DDoS attack, what we do, or perhaps we have a corrupt election server, which for instance could discriminate certain kinds of voters which it thinks could cast votes in a certain way. So all these are quite, if you combine all these things, it's quite a challenge. And what's a typical way to solve? And all these things are kind of solved with end-to-end verifiable, known as end-to-end verifiable e-voting systems. And typically they are based on re-encryption mixnet or homomorphic tallying, which are decrypted, where the votes are decrypted in a threshold decryption ceremony. And how these systems works is that there is an election authority which sets up a public key under which votes needs to be encrypted, and group elements representing candidate choices. So during the vote, voters chose their candidate, and they encrypt it under the published public key. After the vote, all the votes are collected, and they undergo a re-encryption mixnet. And finally, the encrypted votes are decrypted in the decryption ceremony, and they can be counted, forming the final tally. All these steps, the mixed cascade and decryption ceremony, are supported with a robust zero knowledge proofs, so that if any party of there would be corrupt or would try to influence the election result, they would be detected, and the valid election result wouldn't be valid. So that's how it's done. There is, however, quite an issue with the deployability of these systems, and it comes to the deployment of threshold decryption ceremony. The threshold decryption ceremony is necessary so to ensure the vote privacy, so that a single party wouldn't be able to wouldn't be able to know, so the owner of the secret key so the single party wouldn't be able to get a secret key with which it could decrypt the votes, knowing how each individual voters had voted. So to resolve this situation, the key must be sharded between multiple parties. And we need also there is an issue that these parties need to be independent, and we need some redundancy. Redundancy is quantified with a threshold, with number of parties which need to participate in the protocol. And this threshold, if it sets large, there is a possibility that corrupt minority could prevent the election result from being decrypted, whereas low threshold could risk that a corrupt minority would reconstruct the key and know how each individual voters had voted. So there's this delicate balance is what makes it very costly to deploy. So that I would state the statement that a secure deployment of existing end-to-end verifiable voting systems is unfeasible for small and medium-sized communities. And this is supported by evidence where with Ontario 2022 elections. And what's happened there, as I understand, there is some kind of state legislative authority, and it issued that, as I understand, due to the COVID pandemic, they issued that 2022 elections need to be online, and they happen to have some independent, by law, they have independent election authorities in each municipality. So each municipality was in a position to choose what online voting system they would choose. And it's an ideal ground for researchers, and they found, they inspected, made a survey, quite a surveys, and they concluded that during the election, after the election, that most of the municipalities chose black box systems because of and this is my interpretation, because of the deployment issues which are involved in. So, and this is where Peacefounder e-voting system comes into the picture. The Peacefounder system is, the core primitive idea is based on digital signatures. Digital signatures are issued, takes 3 parameters. So they take message, a group element, a group generator, and a secret key. And the public key with which the signature is issued is a generator exponentiated into the secret key. And it is possible also to use the same secret key to issue a signature on a different generator. And this public key then would be different public key, and it turns out that these signatures are completely are not publicly linked. You cannot publicly link them unless you know the exponentiation factor which links the 2 generators, or alternatively there is possibility to construct zero knowledge proofs for the logarithmic statement of equality. Either a person knows the S or secret key with which the signatures were issued. So, and this can be extended in what is known, so this property of unlinkability can be extended in what is known in exponents, when we have multiple parties, in a construction known as exponentiation mix. So what it happens, as you see in the picture, on the left side we can have a list of public keys and a generator, G. And on the right side, we can have exponentiated with the same the party chose some secret factor, and exponentiates our public keys and the generator with the same factor, and provides a robust zero knowledge proof that ensures the integrity of this process. So it's like a knot. So if the individual secret keys are linked by threads in this knot, then we see that the input threads correspond to output threads, but we cannot individually link each other because of the knot. And that's how you can interpret it. And this process can be repeated any number of times with different individual parties, different independent parties. And the output public keys, and when one uses the output generator to sign messages or votes, in particular, they would be linked. We would know that they are eligible to the member set of input pseudonyms, let's say identities, but they wouldn't be individually linked to the voters. So the anonymity in this process, the anonymity and verifiability is ensured at the same time. So this is one part of the picture, and I suggest to read the paper by Heini Spischer on this. The other part is to make the system centralized. I had an idea so to introduce history trees in the for maintaining history trees. And history trees are extensions of Merkle trees with unbalanced number of entries, and they are currently used, quite popular, with the transparency logs to detect malicious certificate authorities, or alternatively, now also Go programming language. This also use them to distribute their packages securely. And the history trees provides two kinds of proofs. One is inclusion proofs. So if you have a signed root commit of the tree, you can get corresponding inclusion proof for any record in the tree, which is of logarithmic size. And consistency proofs. If you have a commit from the some ledger for the root, then you can ask later, some person can ask later on what proves that from the current commit proves that says your previous commit is included, so previous root is included, and that's what consistency proof does. And if random queries by sync clients are done, this can ensure the bulletin board immutability without doing replication. So next one is the implementation of the system. So the bulletin board is split between two kind of ledger types. One is a bright chain ledger, which why it's introduced. So it's this founder system is designed around asynchronicity of available braiding resources, and hence it's based on hence there is a long-lived instances called deems, and in these instances people register the exponentiate, which is called braiding, and can add proposals. And when one adds proposals, there is a ballot box ledger instantiated where the authors can submit their votes. So that's a interesting fast view. And then when the voters when they want to vote, they receive the proposal on their device on the voter client, and this voting client includes a generator on which they need to sign the votes. And when they sign the votes, it is signed with a pseudonym and receives back a receipt, which is in fact, in a simple sense, it's an inclusion proof of vote hash of the timestamp cast index. And later on, some of the voters want to check that their vote is still included, and to do so, they ask for the previous commit index with which they receive the inclusion proof. And when they ask it, they receive back the consistency proof, and if the consistency proof is consistent with the locally stored inclusion proof or the previously stored commit from the server, then they are assured that their vote is included. But if there is discrepancy, if they are not consistent, this inconsistency can be published publicly without any implications of the anonymity of the voter. So that's in this way the system allows the system to be deployed fully centralized. There is the system has a fully centralized responsibility, but the accountability is put in the hands of the voters' devices, of the voters, who can check their consistency proofs. So that's a kind of introduction. There is, and let's go to the demo. There is a link where you can go and kind of follow with Raspberry Pi instance, what I'm going to do. But let's see. So I have opened the Peace Founder client. It's written in a QML, and I have some registration form. This registration form designed for as example how would one do the integration in the existing login infrastructure. So we need an invite. Let's say I input the register. I get invite code. Copy it, paste it, and that's hopefully works. So it takes a time, and okay. So I have registered to the theme, and now I see that there are proposals on which I can't vote because I haven't been registered yet. So let's see, and we see after registration we receive index membership index, and this membership index corresponds to the index of where the record is included in the branched ledger. So it's index 11, and this is our membership record. Now to start to vote, we need to do the braiding. Now we do the self-braiding, but the idea is that one could choose any connect to any arbitrary other themes which would cost the system, and so in this way increase the anonymity set of the vote for the voters. But now let's do the self-braiding, and the braid is done. We can check it what it does. So this is just a metadata out of what we saw, but we see there is some output pseudonyms with which voters can issue signatures. And we can make a new proposal. Let's vote on Y. We can put yes and no. Of course, we can do the configuration. And there is the important part that there is anchor index at which braid, at which generator the proposal is anchored. And yeah, so this is it. The proposal is there, and we can update. We get it there, and we can vote. We can put yes, and we got casted vote. And now the voter receives received. They received a pseudonym alias with which it was cast, at what time it was cast, and the cast record index. And we have also verification. During the vote, there is a small window of small time window. After they cast the vote, they can verify that their devices had cast their votes as intended before all votes are published publicly. So this is takes this key, and it's put in a form, and the form returns from the server on the secondary device how it was cast. So that's the way it works. And so afterwards, so the voters had cast their votes. We can see that they are on the ballot box and tally. We can actually see on the previous. Okay, that's also this one. So they can be. There is possibility for revoting. When the votes are overridden, they can be in some instance malformed. But it's important that all votes which are signed by valid pseudonym, they are included. So after that, the final step is to publish the evidence. And to publish the evidence, the administrator generates a SSH public key, and it can be put into the GitHub repository. Okay, and the GitHub repository, it's as an example shown in Peace Founder demo, and there we have important that we have an auditing happening. Auditing in continuous integration of the records respective to the commits. And to make a sense, this root commit is shown on the voters device, and they can compare it with the ballot box. When they update, they can get the latest commit, and they can compare with the officially announced tally. So when a tally is announced, this root commit root 3 hash should be included, and then it immediately proves that everything by chaining everything together, that so everything can be verified. So let's look back into the Julia. So with regards to the full stack. So the stack of this system consists of around 15,000 lines of Julia code. That's 3,000 lines of QML with some JavaScript and CSS. It's built as a modular monolith, and so some of the essential dependencies on its build is crypto signatures, which implements FIPS 1.4 standards, so what can be used elsewhere. It implements shuffle proofs, which is implements some functionality from Java Verificatum library, and history trees implemented there. And the main module is built in the following structure. There is the bottom, which consists of model, parser, and store, and the audit tools with which we got the green badge is based on the model, which contains which defines the invariants which need to be satisfied, whereas controllers contain different where the controllers define what happens when this single instances are added. And then there is mapper and service on which culminates in the admin panel. So what's the great of Julia for this project? That it's the memory safety and garbage collector allows to focus on the problem itself, to focus on the typing and gets the types right. Multiple dispatch, for example, is binding. So for example, document and signature, there is binding method for that. And in total, for all different types, there is by 37 is binding methods. Okay. So yeah, and there is interactive workflow with revise infiltrator and and short feedback loops and revise enable HTTP request and revise enabled QML. How I use it and some issues I have. So yeah, that's it.
Thank you. I think we'll have to save questions till the end and hand the. But thank you very much.
Yeah.
And hand the floor now over to Megan.
Mm.
Are you okay taking off the mic?
Yeah. Can you please it?
Oh, sorry. I'm not sure. Is there? Oh, it's a clip, is it? Ah. There you go.
Not used one of these before. Testing. Is it working?
Is the mic on?
Do I have to press something? Oh, that's good. Okay, thank you.
Okay, go ahead.
All right, welcome to my talk. So my name is Megan Dawson, and I'm talking about how we use Julia at Fugro. So first, what is Fugro? So we predominantly deal with geodata, that is data or information that is associated with a given location. So let's say you want to put a wind farm in, you've got all these wind turbines, you might want to know about the sea surface or the surface underneath, and that's something Fugro does. We also do things across many different industries, so energy, water, and infrastructure, and we are working towards net zero, and we've pivoted heavily from the oil and gas to renewables. So we have these brand new unmanned vessels, but that's not what I do. So I'm in inspection and monitoring land, and we predominantly deal with airborne LiDAR. So that's where a plane flies along, and it sends a laser pulse, and from the signal return, you know information about what it has intercepted. So like with the road markings from the car example, you can see things that are highly reflective, so those white strips of paint, versus the asphalt, so that's kind of the reflectance. And also, say you hit a leaf, you might get a small peak, and the signal can continue on and then hit the ground. So you can get multiple returns from one laser pulse. One other thing to highlight is we have a lot of data. So on average, we get 1.2 terabytes per system on the plane, and we have multiple going at one time. Now, we have all that lovely LiDAR data. What do we do with it? So once we have our point cloud, our clients often would want it to be classified. So that's where they want to know for each point, what does it belong to? Did it hit a ground? Did it hit the side of a building? We've got turquoise in there for road, vegetation, green, and often we do power lines, so the wires and the poles from the network. Some higher level information we want to derive from that is from those points, which as a group represent one object. So you might have an entire building, they're one cluster of points, or these points all belong to one tree. And then further on from that again, we can derive geometric representations. So if you have your points for your power pole, you can represent it as a top and a bottom, so 2 points in 3D, and that line can be a geometric representation. And similarly for the wire, we can use a catenary equation. Once we have all this information about our world, we can provide some analysis on top of that. So description of the objects themselves, how big is the tree, how big is the building, and how they interact. So is this tree too close to your power line? Now, I'm going to talk about the point cloud classification because it's our most productionized pipeline and how we kind of do this at scale. So our models we are aiming for as being as general as possible, so they can work on lots of different sensors and different densities of point cloud data. And they are combinations of machine learning as well as some geometric bespoke cleanup algorithms. So when we do this in production, we operate at scale on the cloud, AWS, and we also have a very productionized stable build process that goes across different environments. So initially your code, you might be researching, trying, testing things locally. Once you're ready to create your PR and commit it to deploy to the dev environment, that will be reviewed. And then when everyone is happy, on the merge, it will kick off automatic deployment processes as well as automatic training at scale in the cloud. Then we can review it in that dev environment, do some validation, look at our confusion matrices, and then if we're happy, set up a PR to deploy to UAT. When that goes through, it kicks off more automated actions that do some testing on validation data, as well as putting some nice pretty dashboards for people. And finally, to get to prod, our SMEs will test in that UAT environment. All right, so when we do our inference at scale, we have our cluster admin, which is our cloud orchestrator. That's not my team, another team does that. But in that, it's basically a web page where they can select what models they want to run, the data, which has to be uploaded to S3 in the cloud as well, and where they want their results to go. So it will, here we can see that our head node controls our EC2 workers. It pulls the models as well as the point cloud data from S3, and then we'll output it into S3. This is a production pipeline here that had over 3,000 tiles, and it took 15 hours to run. So quite high scale. We can have tens of thousands of kilometers and thousands of millions of points running through. All right, so how do we do this? How do we have our automated build processes? So from the GitHub action, we will build a Docker container. We're running latest Julia 1.10, but we can configure that. And we pre-compile to create the system image, and that will run our full test suite and example cases to ensure it's fast each time. So for each of those jobs they're running, we want it to be as fast as possible. At the moment, we have a very large Docker file. That's kind of something I'm keen to be fixed. All right, so here's an example of our GitHub action. So here, once the PR has been approved and merged, it will bump up the version and build the Docker, so it's half hour to build that. It will release it, so that's copying it over to the appropriate location in the cloud. And then we've got a few other actions here which will tell the cluster admin, here's a new version you need to use. Now for the models, so once you, and it does So from the repo, it will notice the changes to the specific model that you have modified, and that model will be copied up, as well as we have some automated here, is the kickoff of our training pipelines. So those training pipelines, from that GitHub action, it places a message on our SQS queue, and that will kick off our cluster admin training pipeline. And so the model will be updated in the S3 location. Now, here's an example of the UAT. So there is many different automated pipelines kicked off. So you have your UAT Docker, where it will copy the dev environment to the UAT, as well as the models. And this one here is for our test framework. So this is where we have released the new model to UAT, and we want it to run that validation test so we can update our dashboard and also notify our SMEs. It does send a pretty cool little Teams message telling them, here's the model, go check it out, look at the dashboard. I would like them to have a little button, approved button, that talks back, but we're working on that. All right, and then, so this is the testing framework. So the tests are on the different classes specifically, and these are very hard edge cases. So this will be where the little bits of the building are super close to the trees. So these are super hard test cases. And what you can drill down further, so this is the ground one, and you can see there's sort of 3 different test cases we have in there. So if it's nice and flat, we have much higher accuracy at the top. When it gets steep and mountainous, and when it's rolling, we have different accuracy, but still pretty high, 98%. And just recently, we've gone through an exercise to make it a lot faster. So the time that the pipeline takes to run is also measured in those validation tests, and we've got it going down, so we've made serious improvements. That's with compiling the system image, as well as rolling forward to the latest Julia, and some internal changes we made to how we buffer and handle our tiles. And that's it. Any questions?
Any questions?
So do you retrain the models every time you have new code deployed?
We retrain the models if the model changes, but if the Docker or the code that's run, let's say it's a small bug fix for something deep buried in one of our packages, we won't necessarily need to retrain the model.
Any more questions? No, then I think we'll thank you again, and we have a short break, and then we reconvene in 10 minutes. Right? 5 past. Yeah.
That was nice. Sorry. It was fine except the noise was. Oh, the drones were I don't know what the drone was about.
Yeah, that was weird. Your talk was really cool. I really liked it.
Yeah, if you want to see demos of the bits like with demo times, happy to show them.
Yeah, that'd be cool.
Yeah, but not now, just yeah. The next talk down there.
Like way back you asked me about the XSD tooling, right? We're almost there. So I got the okay to publish it about a month ago or something. So now it is living in It's not public. I still have to go into like registration.pl, but it's when it's starting in general registry, and then it's out there. And once that is done, we still have to backport it because we started the open sourcing process in December, but in the meantime they needed bug fixes and new features, so we had to keep it out. But we couldn't change the code that was about to be open source because that was under review, so it was sort of frozen. So now that it's out there, it's going to be 0.1, and it's going to be like a big disclaimer saying, like, hey, there's some stuff coming down the pipeline, but we still need to first do the backporting, and then that pull request to the public repository also has to be reviewed again. But luckily, but hopefully it's going to be a bit faster. Because now, because they say like, oh, it's the first one open source in Julia, the X was the first one, but they didn't know what they didn't know about this one, so they had to go like a whole process. I had to go back to legal a few times because they were, oh, I'm certain if you're following the license.
Well,
no, it's fine. So
Okay.
I'm glad that at least it's out there and almost
Almost published. Yeah, that's fine. We might
back in March.
Yeah. Yeah, because it's one of those things that if you really have to do it yourself, it's a pain. I know because I've done it myself.
Yeah.
It's a painful thing to do.
Yeah, right now our solution is to not do it.
Yeah, it's just ignore the schemas and just load the XML. But that has its own issues.
Yeah, no, not even that. It's like we are avoiding doing.
Oh, right.
Like essentially, there is a pipeline of people are creating this thing, and there's some people maintaining this, which is not exactly. It's like an internal format for TNO, and then we want to use it here. So this conversion was maybe happening here. So maybe we're considering to say, hey, instead of giving me this, give me something else.
Oh,
and
yeah,
then
you can
and we just change to the map.
We're almost there.
But it's pretty nice.
Yeah, so the one thing I kind of want to make sure that works is that currently, because we have 4 packages, and so if you run the tests for one of them, you want that one to use the latest version of the other ones, the one that's in development.
Yeah.
Because if you just run your test pipeline, it will take the one that's on the registry. But since you're updating one of them, you're probably updating no other one, so you actually need the working version.
Semantic version.
What? No, but you need to once yes, but you're still running the test pipelines before you publish it, right?
You want to test all of them together?
Yeah, with the working versions.
The way I resolve it, I have a root directory under which I have different packages.
Yeah, I have it set up in some way.
In this root project, I have
because when you look it up, it's like what our other projects doing is, oh, we have this nice GitHub action. It's like, oh, just do Julia build, and it builds the whole thing. But of course, that just downloads everything from the general repository. So I have this first phrase say like, no, pick this other one, use the one, and it's a small thing, but
so we do something.
Also, the root project helps with the revise. If you find some plugin deep in the module stack, you can find it
So what we do on JSO, a few packages, is we do for PR testing. We test on the release version and on the master, probably master version still.
Yeah, so the reason why I'm probably not going to do the release version is that these packages are so interconnected that usually if you make a change to one of them, you're making a change to almost all of them anyway. And then you'll just see a bunch of failing tests because usually it's something like, oh, there's something changed in the very first package which impacts all the other ones. So then it will just keep failing.
But do they have actual graph dependency? Can you just take a package out of the other tree? Like, hey, this package by itself exists. Can I use it by itself, or doesn't?
No, it doesn't make any sense. Because
why not merge?
Because basically, why merge them is because there are use cases where you use the output of one of the packages in your package, but not that package. But then, okay, so it's a bit difficult. I had like this whole diagram in my talk. Because you have like the XSD to struct, which outputs things that are then used by the loaders and the writers. And your package might likely use the loader and the writer, but not the XSD to struct itself. It might just use the output of that, but it wouldn't include that as a dependency.
Directly, yeah. I get it, but I'm thinking like if you can release like this is version 1, everyone is version 1, and just version 2.
Theory, yes.
Then it just
but
works.
The problem, what you quite often see is that a particular version of XSD to struct to work, because it's assuming that the structs that come out of it have certain properties, work in a certain way.
But it's still that's normal semantic versioning. I mean, we are
so
breaking the API.
So the Semver part that's perfectly fine, but it's more or less like running the test pipelines when you're doing a PR.
Yeah, that for sure we have a solution.
Okay.
Yeah, I mean even using the latest version of the dependent. I mean it's not a great solution. It's 5 years old at least.
Because something that we were doing when we were developing it inside at ASML was that we always had like, before we can merge the pull request, because there were really 4 different repositories, then before we could merge the pull request in like the loader, we first had to merge the pull request in XSD to struct, and then register the new version. Then we can go to the pull request for loader, run all the tests. Oh no, we found a bug in one of the tests that we didn't see locally. Now we have to go back to XSD to struct, make a and then sort of keep going. But it has happened too many times because it's sort of there's this sort of cascade. You have the abstract types.
Okay, we're into the final lap of this race. I'm not sure race against what, but we'll start off with Bradley from Julia Hub talking about Julia Backend and how it helps. Well, I won't read the title. The floor is yours.
Thank you. Okay, so yes, my name is Brad Carmen. I currently work for Julia Hub. In my past life, I worked for Instron, and this talk is an industrial talk about kind of the work I did at Instron and how I built an app with a Julia backend running a model. And the reason why, there we go. The reason why I kind of focus on model-based app development is because building models is not easy. I like to say it's like the most challenging programming that a programmer can do because a model is solving a system of equations all together at the same time. And if there is a problem, there's no way to get a useful error message like you can get in other types of programming. I'm sure some of you doing very challenging work can argue that maybe that's harder than model-based programming, but it can be very hard, right? So if you build a model and you want to do something with the model, and then you want to package it in an app or something that you can share with someone else, there's a lot of friction that comes from that, the fact that models are so challenging to make. So in the world before Julia, building models is generally done with some kind of modeling application to help you build a model, right? So there's like Modelica, for example, is a tool that helps you with solving those insanely hard to solve differential equations. So the thing is, these tools that are help you build models, they're not full-featured programming language. They're just tools to build models. So if you want to take that model and do something with it, it gets converted to C or it gets compiled to a binary, and then you can take that and do something with it, right? So that means that there's like this wall that exists between the model and everything that comes after it. And that wall creates some serious friction in being that you lose useful errors. So if what you're doing with the model over here causes an error all the way over there, you're not going to get an error message that says, it's not going to be an error message at all. Probably it's just going to crash the app, right? It's just going to. So I've been extremely frustrated for a long time with that scenario. The other thing that you lose is model context. So what I mean by that is when you're in the modeling application, you'll have a nice schematic of the model that you're working on, and you can click on a component and see what variables it has and say, I want to plot this variable. And as a human, you can interact with it and make sense of it. But after it goes over that wall, it's just C code, and it doesn't know anything about what it's computing. It doesn't know about that component that you want to plot, and therefore you have to make all those decisions up front about what you need to export from the model and what you might want to plot in the end. And so if you are over here developing the app and you realize, oh, I wish I had velocity instead of position, well, you're out of luck. You need to go all the way back to the beginning, make sure you export that, and then you can come all the way back to the app. So that creates a lot of friction. Okay, so this was the world without Julia. This is the world with Julia. So the whole point is there's no more wall. You're working with the model here at the app stage. It's the same backend that you had at the very beginning. You don't lose that context. You don't lose useful errors. And that is game-changing for how productive you can be once you get to the front-end development stage. Okay, so I forgot to mention, so you'll see that it was supposed to be myself and Avinash speaking today. Hopefully you didn't come to see Avinash and you just got me. Originally the plan was we were going to build a model of some really advanced models that Avinash works on. So he builds HVAC models. They're super advanced, and I wanted to make like a cool app that showed off that stuff. But yeah, time escaped us. So instead, I made a very simple app of a model of just an active suspension system. So we have a wheel, we have the the mass of the car, and then we have a seat. Each of these are just like mass spring dampers. And then there's a force that is acted on the seat to give this like active suspension, and a little controller to try to keep the seat from bouncing too much. So I built this model using Modeling Toolkit. If any of you out there are need to build a model, something like this, and you don't know about Modeling Toolkit, definitely look into it. It is, essentially Modeling Toolkit replaces that model building application that we would use before. So it's very similar to Modelica, for example. If you've ever used that, Modeling Toolkit will be completely natural to you. So anyway, that's my model. It's just these components, they're connected together. That gives me active suspension. So to prepare this model to be in an application, which maybe makes sense if I just go and show you the app real quick so you kind of see what this is all about. So coming from industry, I use Windows, which is, I think, kind of rare in the Julia world. So I built applications using Microsoft technology. So this is an app that's built in C# using WPF. And what you see right now is exactly that. And this app does this. So I just add a simulation, I click run, I get results. And what these results are showing you are the position versus time. So the first line here is the road. So basically this is just a bump. The next line here is the wheel. So this is the wheel going over the bump, and then it kind of wiggles. This is the car frame. It wiggles even more, and then the seat wiggles a lot. So basically the passenger, after he goes over this bump, is really not happy, right? So that's what the app does. And I'll go through now. And let me also explain here. So we have parameters that we can change. So what you just saw was active suspension not working because it's turned off, essentially. Okay. I can go ahead and turn it on, run this again, and you can see now that the bump is a lot smoother. That's what the active suspension is supposed to be doing for us, right? So that's what this app does. Very simple. So let me go through some boring technical bits about how I got that to work. So I needed to prepare a way for the app to change the parameters, and those parameters to get to Modeling Toolkit. So in Modeling Toolkit, the component looks like this, where you define parameters, you define variables, you define equations, and then you assemble an ODE system. And so the parameters are just values. So in Julia, I create a structure that maps to the same set of values that this component has. And what I can do is create a broadcasted dispatched function that maps exactly those values of the struct to the values of the ODE system. And you'll see why I do that in a second. So I have certain parameters for certain components. So there's a road, there's a mass spring damper component that makes the wheel, the car, the seat. And then there's a controller parameters. So I put all those together in one final parent structure. And then I do this broadcasted trick again, so I can send this guy as a list of parameters to the system. So the system is mapping to those parameters, and this is making an ODE problem that I can solve. So this is all Modeling Toolkit differential equation stuff. But this is how I can do it. So I can make a function that I send the parameters to, and I get results out of. That's simple as that. Okay. So how do we do this once we go to the front end C# code? So I have a package that I've made. I haven't published it yet, just exists as code at the moment. Julia to C#, that allows you to take those structures, so the road parameters, controller parameters, system parameters, and generate C# that maps them to the Julia structures. And then I can also take the methods that I made in the Julia code and map them to C# so that I can call them in the Julia backend without having to write a bunch of wrapper code. So this writes the wrapper code for you, okay? So a little bit of details of how that looks. So if I generate this road parameter structure, it's going to generate an initializer for me in the C#. I'm going to be sending this the pointer that I get from Julia. It's going to put that in it's going to protect against garbage collection, because if I'm going to hold onto that pointer in the front end, I need to make sure that Julia doesn't delete it from me. And then I can take that pointer and marshal it to a structure that I define in C, which matches the structure that's in Julia. And this all works somehow, but it works because the structures that are defined in Julia are type-based, right? So I can make sure that I just match the same types in C#, and it works. Okay, enough with the technical bits. Yeah, so how do I get that pointer in the first place? So when you embed Julia in C#, you essentially have this JL eval string function, and you can use that to call the Julia. That's one of the ways to interface with the Julia backend, right? So I can call that, and I can get a pointer to an empty structure of the system parameter structure. So then I send that pointer to the thing I was just showing you, and that populates that structure in the C# world. And then I can do something as simple as do show parameters, which calls this function I made in Julia that's as simple as this, which is saying display the parameters. And it works. It will print out the parameters to the standard output. And so in my C# app, I can just have the console showing as well, and that's where I can capture all that output. All right, so how do you embed Julia in C#? What you need to do is call this JL init with image, and where that comes from is from libjulia.dll. So if you were doing this in C, it's a lot easier because you just need to include the header file, the julia.h file, and then you get these functions for free. In C#, you need to do DLL import, and then you need to make sure you match the signature of the function as it would be in the header file. So to launch, so you launch your C# process, and then you call JL init with image, and then you have the Julia backend running inside of that process. So they're sharing memory. And you just need to give it the technical bits of where's the Julia executable, where's the system image, and then where is your load and depot path. And the system image, by the way, right now I'm just running the standard image, but when you're ready to deploy this, you can use package compiler, generate your system image with all of your code already compiled, and then you can ship that system image and point to that. Okay, so yeah, getting back to getting rid of that friction, why this is so cool to be able to do this. So here's an example of a useful error. So in the Julia code, in my module, I have a set property set for this mass spring damper. If the mass is below 0, it's going to give an error, right? So very simple thing. But this is the kind of thing that before Julia, if you did this, you don't get a useful error. It just crashes the model, right? And you might spend half a day trying to figure out like what the heck is going on. But now, if I try to enter in a negative mass, I will get the error message that was coming from Julia directly, Comes all propagated all the way up to the application. And then model context. So what I'm demonstrating here is that I can enter in whatever variable I want to plot at any point in time. So I'm doing this as the application's running. I can actually ask for a different variable than I intended to have in the very beginning. So yeah, I think that's enough said. It just works, basically, is the really cool thing. And one other really cool thing that you can do is you can actually run revise. So if you're building a very complex application and you're trying to sort out what's happening on the front end and you need to make changes in the back end, you can actually make revise happen. So I'm just showing an example here that I forgot to include gravity in my equations of the model. I could see that the truck is taking off instead of staying on the ground. And I can go ahead and fix it. So you just need to make sure you run revise when you launch the app. You fix the code. This is some bit that I don't truly understand. When you're embedding Julia, you don't have the REPL running, so there isn't this thread in the background. And revise is a little different when you do this, so you have to manually call it. But it works. And as you can see, I changed my code. I left the app running the entire time. I never closed it. And Julia did its thing. It revised, and then I ran and got the right result. So that's something that's very, very cool. So I only have 5 minutes left, so let me just pause for questions now. See if anybody wants me to say anything. Yes.
So that C# code that's generated, you save that, or
Yes.
is it generated every time you run the executable again and then insert it? So if you change the Julia struct, for example, you need to actively change your C# code.
Yes.
So that needs to stay in sync.
Yes.
Manually.
Exactly right. Exactly
Okay.
right. So I have a code gen script that I just have in my module. So if I update my Julia code, then I just need to remember to run that code gen. But then you just do it once and you're done. Yeah.
Any more questions?
So there are already GUI frameworks in Julia like GTK and QML. What were your reasons why you chose C# to building the GUI?
Partly it's just because I know it.
Yeah.
But I've also played with these other. It would be nice to just do everything in Julia, right? But they're not as mature as WPF is extremely powerful. So you can, they've been developing this front end technology for a long, long time, and you have nice coding patterns, and you can do some really powerful things. So, yeah. I'm looking forward to Julia getting to that point when we.
Yep, nice talk.
Thank you.
I have a question to the structure I saw in C#, if I understood correctly. So, for example, if you put there double char double, and you now have two compilers included, a Julia compiler and a C# compiler, what if one of them thinks to add 7 empty bytes behind the char? Is it so the alignment of the memory, does one need to be careful there maybe? Or you didn't, nothing happened, everything was fine?
In theory, the structures, part of what I've done my best, and I'm not an expert in this stuff, but I did my best in this package to ensure that that doesn't happen, right? That the structures will line up and the memory will line up. There are sure edge cases I have failed to do correctly, but I have done lots of strings and vectors and numbers and then complex structures inside of structures and structures, and it all works so far.
Okay.
Yeah, so.
Okay, thank you.
Yeah. So here's the codes. If you're all interested, please check it out. Please help contribute if you find this interesting. I'd be happy. Yes.
As far as I know, creating the sys image is very important
for these presentations.
Yeah.
So the package that depends on the binary builders that works well with creating that packages that works well with when creating the CS image.
So your question is, when generating the system image?
Yeah, there's some package that depends on the binary builders, right? Some libraries made by static flows. So
the thing is, I'm not sure the binary building has anything to do with this particular path, because building a system image is there's really no difference. It's just, in this case, pre-compilation happened, and all that pre-compiled Julia code went to some folder. Package compiler just puts that all in the system image, is my very simple way of seeing it. So it will work. You just do package compiler, and then you don't need to include all, and then you can just ship that, and it should just work. Yeah.
Okay, thank you.
Yeah. Oops.
Maybe time for another question, if there's any.
And I feel your pain about the size. Yeah, because the system image can be quite large. The one I was generating before was 1.2 gigabytes was the size it got to. So
there was a nice talk at last year's local JuliaCon by Jeff about the binary sizes, but I'm not sure how. He said they can get them way down, but I'm not sure how easy it is and how there were some risks involved.
Yeah. Yeah, unfortunately it doesn't sound easy, but...
Yeah. Okay, then let's thank... I was going to say again, we didn't thank you before.
Thank you.
And then you're up. Do you need a hand with the microphone?
Yes, please.
Oh, I think you got it. Oh, no. I think they turn it off for a while you're...
That's a good idea. Feels weird.
Any?
Yeah. Thanks. And can I grab the clicker?
Clicker, there's a clicker here.
With a dongle?
I guess, is this the dongle then?
I think so.
Oh yeah. Oh yeah, there's a 3.
Mode. Hi, I'm Lauren Clisby.
Oh, yeah. Sorry, I was going to hand you the floor with one of the nicer named packages I've come across. The floor's yours.
Okay. Oh, here we go. I'm Lauren Clisby. I work at TNO. TNO is an independent research organization here in the Netherlands. We do everything from quantum computing to healthy living. I work specifically in the energy and materials transition. So we work in the energy transition from fossil fuels to green energy. And just a quick quote, Mark Rutte, the last Prime Minister of the Netherlands, compared the transition in the Netherlands to the efforts of rebuilding after the World War, so World War II. So that's a little bit of what we're up against. So what kind of questions are we trying to answer? Investment decisions on the energy infrastructure, the impact of the generation mix, demand, different energy prices, and other factors, impact of policy targets, which is really important for the government to know, level of security of supply of the system, so if we're completely reliant on renewables, what happens if there's no sun or wind, and of course the grid itself going down. And for cross-border connections with, say, Germany and the Scandinavian countries, so how do those things affect our system? So where there are a lot of decisions to be made and money, then you have modeling. So we have energy system optimization modeling is what I work in. Very basically, you have two problems. You have the investment problem, which is how should we build up the energy system for the minimum cost? Your input is then your current system, your future demand, and what options you have for building up. And your output is then the new system and how much that costs to build. Then you have your dispatch problem, which is how will an energy system function throughout the year to satisfy demand, also for the minimum cost, because it's an optimization. So then you give it the system that you just built and the expected weather and demand profiles for a year, usually. So your weather and your demand. And then you get out production, where it happened, where things were converted, and your transport through the network, and your storage. So you just see how the whole system functioned over time. So why is this difficult? Well, this is just a toy problem. This just shows electricity, but you could also have gas. You should also have hydrogen. You could also have heat. Those systems interact with each other. They have different levels of technology detail that you may want to include, depending on what you're looking at. I said the Netherlands, but you could also be looking at all of Europe, for instance. And the biggest dimension that we have is time. So if you solve this once, you would just know if your total energy for the year satisfied your total demand, but that doesn't tell you anything about time. So if you wanted to solve on, say, a monthly basis, you have to solve 12 times. And if you want to solve on a yearly basis by the hour, you would have to solve it 8,760 times. And if you want to do multi-year analysis, which a lot of people do, then you multiply that by how many years you want to do, and the problem starts getting very large. So if you've worked in optimization, you may be thinking, that's maybe too big to solve. And the answer is yes. If we actually include all of the details that we want to include, the optimization is too big to solve. So then we have to find ways of simplifying. So take this elephant, for example. You could probably simplify this image a bit, and you could still know that it's an elephant. It still looks like an elephant. But if you simplify further, then it starts not looking like an elephant anymore. So this is sort of the game that we're playing of trying to simplify where we can, but not simplify so much that it no longer looks like what we're trying to model. Some models do this, which is to just focus on the thing that you're looking at, but then you don't see the full picture. What we'd really like to do is this, which is low resolution, where you don't really need it, maybe medium resolution, where you kind of do, and then high resolution, where you're specifically looking. So this is what Tulipa Energy Model, which is the project that we work on, is very good at. It's good at balancing precision, but also having simplification where you need it. So 3 innovations that we have that do that. One is with time resolution. These are my colleagues who developed this, so if you're wondering what the pictures are. Normally, time resolution is either hourly or maybe you can have multiples, but those multiples you can have multi-hour, but they have to be multiples of each other. So usually you just have to pick one time resolution, and then you're stuck with that for your entire model. We have fully flexible time resolution, which means that you can change the time resolution for different parts of your model, and you can scale it up or down depending on the type of detail that you need. So ways that this is useful is if you want to have different time resolutions for different energy carriers. Electricity usually needs to be on very high resolution, whereas maybe heat can be on like 6 hourly resolution. You can do it by your geographical region. So if you're specifically looking at the Netherlands, you maybe want high resolution for certain things, and then lower resolution as you work your way out without completely removing them from the model. And you can do it by time horizon. So you could say, this year I care about higher resolution, but as I look to the future, then I can go to lower resolution. And you can combine them if you want to. So you could have really high resolution for electricity in the Netherlands and then have lower resolution. Anyway, so you can combine them, which is also great. Representative days is a method of reducing also the size of the problem by, instead of solving for each individual day, you group them. So you say like, all hot days, I'm just going to solve them as the same thing. All cold days are the same thing. The thing is, you're playing a game between how many days you have, which better represents your data. But the fewer days, the more computational gain that you have. So we use a method that better represents the data, because instead of throwing the days into a certain bin, you actually make them a blend of the different bins that you choose. We didn't invent blending, but actually the method that we use does a better job. So a standard method is on the left, the original data is in the center, and our method is on the right. So you can see, basic as an example, that the data is much better represented. And we have a compact core formulation. So we're dealing in optimization. You have a certain number of constraints and variables. And our formulation reduces the total number of constraints and variables to solve the same problem. Which just means any problem that you're dealing with is in a smaller size to begin with, which allows you to scale to larger problems if you want to. And it solves faster. So this is Julia. Let's talk about some Julia. In case all of this lack of code is making you itchy, you can go check out our repo. We use Tulipa Energy Model as our core repository. This is what builds and runs the optimization model. Tulipa clustering runs the blended representative periods that I talked about. And Tulipa IO is our script-based data manipulation because the way that the model runs is highly dependent on your data. And we don't really give them a GUI, so they need to prepare their data. And these are the dependencies that they run on. So Tulipa is using data frames, Jump, which we're super happy about, which is why we picked Julia, and Graphs.jl. Tulipa clustering and is using clustering and distances, and DuckDB is a open source database manager that Tulipa IO uses. We also are very happy with all of these packages. Bestie template is a template package for your best practices developed by Abel in the audience. We're testing, documenter, benchmarks, Julia registrator. And we're going to do our visualizations in Pluto. So we're looking forward to that, but it's not included yet. The pros and cons. So we're really happy about the speed and efficiency. We're researchers, so we're not programmers. We needed help getting started. So it's nice how user-friendly it is. But it's also very fast. We need efficiency because of the size of problems we're dealing with. Straightforward syntax, like I just said. It's super friendly. Jump is a major gain. We also slightly considered Rust and then realized they don't have optimization and it takes way too long to program in. And all of the nice packages like DuckDB and Documenter and everything. Things we've had a little bit of challenges with is you can get the speed and memory efficiency, but you need to know what you're doing in order to get it. How to optimize memory use isn't exactly self-evident. Sometimes you don't know when allocation is happening. Compilation can be slow, and recompiling is annoying, even when you change like minor things. Errors in debugging, the stack trace is way too long. Even when you have a small error, it can give you a huge stack trace. And with interoperability, we've run into sometimes the other packages are Python-based, and then and then they don't have very good Julia support. And because Julia is a less popular language, it's less of a priority for them to support it. So just really quick, we had this. This is a good example of like the size of problem that we're dealing with as far as variables and constraints. But it also shows that our initial code, which took 314 seconds and 32 gigabytes of RAM to run, once we switched to data frames and sort of refactored to get more savings, then we got down to 86 seconds and 18 gigabytes. So that's like a example of the first way that we did it didn't actually go fast enough. So we had to spend this time to really optimize how Julia is happy to do this type of problem. And here's my lovely team. We have TNO. The Netherlands eScience Center is also here. They're a software engineering company that helps researchers to do better code because we're all researchers and we don't know how. And we're also working with TU Delft and Utrecht University on the innovations that we're incorporating into LIPA. So that's all. Very quick.
Thank you.
All right. Do we have time for any questions?
Maybe one quick question. I saw you first.
So for all your energy models, do you depend on other packages which implement these models, or are they all like homemade? How can you, like, which models do you implement and what features?
Sorry, what do you mean?
Like, you're modeling, I assume, your generators, the electricity grid, maybe the heat markets, all these kinds of things. There are a lot of packages in Julia already, for example, to model power flows in a grid, or like, do you have your own formulation for that, or do you depend on other packages?
So I should have specified this isn't physics modeling. So this is a more large-scale system model where we don't take into, we just generalize, we don't take into account like complex system physics. So instead of having your like heat dynamics and your electricity dynamics and things like that, it's more of a Amsterdam has this much electricity production from these types of sources, and it can transport it to Rotterdam. So it's really like large scale. We have certain constraints that account a bit for physics, but not in the level of detail that I think that you're talking about.
Yeah. So it's market coupling based and those things.
Hand off, more questions, anything?
I saw one more question over here somewhere, right?
Yeah, I think my question went kind of in the same direction. So it's about, are you aware of power models and power simulations? I think power simulations is doing kind of a similar thing, but also with a bit more infrastructure and physical modeling behind it. But yeah, it's kind of the same question.
Yeah, this is MILP, so mixed integer linear programming modeling, not physics modeling. It's also not really market modeling, which is another type of modeling, and we don't consider it simulation, which they also do power system simulations, but we're doing, optimization. So I hope that's what, in the direction you're talking about.
Thank you.
Okay, let's thank Lauren with another round of applause. Is that okay? Oh. Okay. Now the thing that I've been looking forward to all day, the panel discussion, which I invited 4 of the speakers, so Lauren, Brad, Megan, and Gareth. Sorry. So, right, a conference like this is nice to share your ideas you had before you came here, but I think it's also good to actually interact. And this mini symposium was about people who are using Julia in an enterprise context or organizational context. I call it Industrial Julia, a name I've been resenting for a while now, because everyone thinks about factories and stuff. But we had several questions I thought it'd be nice to get some input on. And maybe I'll ask someone from these 4 first, and then other people can also chime in if they want. If it works. I seem to be stuck on this slide. There we go. Okay, so why was Julia chosen for your project? And I'd like to hand the floor to Lauren again for this one.
Because we first are not programmers, so we didn't want something very difficult to program in, so user-friendliness was definitely important. But also we need computational efficiency and RAM efficiency because of the size of the optimizations that we're doing. So yeah, we needed a combination of both. So that's Julia.
Anyone? Wait, am I? I'll use this one, okay? Anyone want to add to that? And if you also have an opinion on why?
Yeah, for me, I already told you there was a basis in C++ and CUDA, but which was not ready, and I just took this decision on my own because I was way faster using Julia than diving into CUDA code, and that was the reason why I did it. I just didn't ask, and they let me do it, and which is really nice. And I also made the compatibility to the Python guys, so it's very okay to call Python code, and also vice versa. So that's also maybe one reason why Julia is cool, because you can also combine it with other languages.
Yeah, so we've been using Julia for a long time. The original people, like Claire Foster and Andy Ferris, if anyone knows them, so they started when it was 0.4. So we've been using Julia since the very early days in production. I can't speak for why they migrated towards it, but certainly we continue using it because it is fast and efficient and easy to use.
Yeah, I think I could talk about this one all day. Julia solves just like so many. It's like an engineer's dream come true, because the two-language problem just creates so much friction. And so my presentation was like all about it, right? Like having to develop an app that goes from the very beginning of the story to the end of the story. That two-language problem just kills productivity. So being able to not just write in this nice, simple to write program language, but it's also fast, means that I can do what I showed in my presentation, where I can build a backend, make an app that has this very complex model in it, but then I can also use that model like very easily outside of the app. And it's all the same interface. I just write one module and it works everywhere I need it to work. I don't have to deal with compiling it for this and then compiling it for that. So yeah, that's maybe 10% of the answer there, but
okay, thank you.
Good enough.
Let's move on to the end of the slideshow. I beg to. You know, during the break before the mini symposium was this thing kind of showing the program, and that's why everything's messed up, because I tried to be fancy with PowerPoint and I wasn't using PPTX. Megan, I have a question for you. Did Julia make true on the speed promise? And did it do so easily? Maybe that's also a second part of the.
I would say it does so easier than, say, using C++. We do have teams that have tried to tell us it'll be a lot faster if you just do it in C++. But when we do benchmark, if we're doing our jobs properly, it is comparable. So I think, yes, it does.
Anyone beg to differ?
We're still working on it. It does, but you need to know what you're doing, and also the community is smaller, so maybe someone hasn't done your specific problem. I don't know if Abel, you want to comment on it, but we're still looking at new ways of implementing that will handle our data in a fast enough manner. So
I concur. You have to know what you're doing to get the speed, for sure. I remember the very first time I'd used Julia, I was expecting this like magic to happen, and it wasn't. It was super slow, but it wasn't that much work to get it to be fast. But I'm definitely in awe of all of you brilliant people out there that can somehow make zero allocations happen and get this insane speed. But the nice thing is it's so composable that I can use what you make to make my code fast. And so, yeah, it's work. It definitely, the promise is true. Yeah.
So I don't necessarily need an answer from everyone on every question, but I'm still going to ask you, Gerard, because you are the one who showed that your code is actually not fast enough yet, right? Are you confident? Are you really confident to be fast enough at the end?
Yes, I think so, because just these days I made a progress of factor of 100 for one small part.
Okay.
And I have to say I really started very simple and just plain code and not thinking about too much about optimization. And I think this is a stepwise approach. So first you make a prototype, then you test it, and then you integrate it, and then you think, okay, let's make it fast. And I think that works well in Julia.
Thank you. Yeah, I have another question for Brad. This is a question this is when we were discussing questions for the panel. This was the first question we had. What one feature would you like to add to Julia?
Okay. I know I had a good answer to this question when you asked, and now I forget exactly what I was going to say. But I definitely, the system image size, I think we all agree that could be improved. Julia's great once it's pre-compiled. Is another one where if that pre-compilation can just really be frustrating sometimes, waiting for that. So if those 2 bits get fixed, the list of things that I need is not long. Like I'm a very happy customer. So.
Oh, really? Anyone want to chime in? Oh, Xander wants to say something.
Yeah, I asked a question about that. So I was also wondering. I think Lauren, you also mentioned like the painful pre-compilation. Do you have some wisdom on how to? I can imagine that if you, for example, keep your environment clean, it will help. Like your pre-compilation happens for all packages that are affected, and if you have less packages that are affected, then it helps. But are there other like things that you can do to, or that you've noticed that can reduce the pre-compilation time? I guess for any of you.
Some packages are just nasty.
Yeah, exactly.
Maybe you should pass the mic.
Yeah, some packages are just nasty. They just do nasty stuff, especially if they're extending each other a lot, and then there's a lot of cross-pollination between these different packages, and then they extend each other, and they keep extending each other. Every time you load a new one, it's revalidating, or it's invalidating everything it's already done, and it does it all again. Like I have packages that have warnings in them, and I just see the same warning getting printed over 100 times over and over and over, because every single time it hits the same code path. So there's so much waste going on, basically, where it keeps invalidating things and then recompiling, invalidating, recompiling. It's like, why are we doing this? So in certain cases, you can't do anything about it.
But is that certain dependencies?
I'm not going to call anything out.
So maybe you should avoid some dependencies. Any other of the panel want to suggest a feature they definitely need or would really want?
So I'm really looking forward to better help to understand what Julia is doing so I can optimize it. And I saw very cool features which are coming, so to make the profiler more explainable, more useful. And I also learned with the mentoring how to really debug CUDA and GPU stuff. And so Julia can be more expressible, so we can understand it better. And I think this will be a cool feature which just will help us to make it faster, I think.
This mentoring, because I have the impression during a talk this morning, it was mentioned that there should be something like that, but apparently it exists. Is this like a hashtag on, you said Julia Mentor, right? But is that?
Yes.
Where is that?
At the JuliaCon, when you registered, you could apply as a mentee or mentor. And I got mentored with Julian, who is working with the Dagger package, and we just had a session. And
but is it on Discourse or something, or is it via JuliaCon?
Via JuliaCon, yeah.
Good to know. Thank you. I think I have another question, is how do you experience the interoperability? We're going to ask to Gerard first.
I worked with Python, and it was a bit difficult in the beginning. There were two different versions. There was PyCall, now it's Python call. There was Julia, now it's Julia call. And I managed to do it. It was a bit of work, but I'm happy that it works because I'm also using Python packages from Julia because it's not integrated in Julia, and this interoperability broadens my possibilities. And I'm also looking forward to using C# because I'd also like to use Julia within C# in an app in a game, and not sure if that works, but that would be also super cool. So check it.
Anyone else?
I kind of mentioned it earlier, but I was choking, so maybe you didn't hear me. We have a bit of problems with, not so much on the Julia side that it doesn't work with outside packages like Python stuff, but more that because the mentality is so much, oh, everything works on Python, that if you have something and you're trying to do it with Julia, then they don't support you as much, or they just haven't even thought of it yet. And it so far has worked out, but we had, for instance, one bug that we said, hey, could you fix this? And they said, well, you guys aren't a priority on the Julia side, and then it was fixed in another, like for something that they were fixing for something else. So it happened to be fixed, but it was a dependency that they just weren't going to do. So that's a little bit, like, as it grows, it'll be less of a problem.
Okay. Maybe I do have some more questions if you want, but I'm also quite interested in what the people in the audience think. Otherwise, it's going to be a bit of a Sioux show. So any other questions from the audience for one of the great panel members here?
Hello, my question might not really add to your story, but I'm curious if anyone in the industry is using static analysis of code for the correctness and for security reasons.
Anyone? Oh.
Yeah, we had a very quick slide on it. We use Documenter, Julia Formatter, we use pre-commit and linting and everything. So ours isn't really for security or anything, it's just to make sure that our code is pretty and we don't make dumb mistakes. And so that it's intelligible for future programmers. But yeah, anything I missed? I think we have. Oh, yeah, basic.
Yeah, so one of the things that is a thing. So this was added, I think it was last year, and not all of it is available open source or for free, but there's this tool called semgrep, which is a linting, quite advanced linting tool that is capable of doing things like, in other languages at the very least, detect things like OWASP, common vulnerabilities and things like that. Not 100% sure those have been implemented for Julia, but there is Julia support in semgrep. So it's technically feasible to write the rules to find common anti-patterns or potentially security-related bugs in code statically using a tool like that.
I don't know enough about Jet. Yeah. Coming your way.
I think your question was whether industries are doing that. So I work for ASML, like many people here. We're actually using semgrep and extending semgrep precisely for that reason. And there's also, we're now looking to Jet, also for static code analysis to see whether we can get more valuable direct feedback, whether the code is indeed ready for static compilation. So that is typically how we try to address it and see how far we can get. Yeah? No guarantees though yet.
Any other questions from the audience? You're making this a workout for me now.
So I'm curious, how have you found, say, the maintenance of large internal Julia code bases? Because, I mean, my experience at past companies with large Python code bases has been generally pretty good, lots of good tooling around it. But with even just sort of small to medium-sized, we've struggled a lot more. So, yeah, interested in any advice you've had. Thanks.
Anyone from the panel? Yeah, okay.
So we do have a large code base. We probably have about 100 private repos and our own registry. And we have had to make sure we roll forward and keep everything up to date. So yeah, like I said, we've gone from 0.4. We went to a process to get to 1.6, and now we are consciously always using the latest, so 1.10. And we are making the effort to always roll forward with it because we have had in the past problems with version changes. So that's one thing I'd say is try and keep up with it. We also always try and pull and build whatever the latest packages are. If you want to, you can get in a nasty habit of fixing your issues by just changing your compat, whereas it's always better to keep everything going.
Thank you. That reminds me a bit of what Michael mentioned, right? You already had some Julia backlog issues, and I guess the best way to deal with technical debt is to not to have it. But I think we're running out of time. I do want to ask about that. I'm a bit annoyed. This was like we asked the question, one thing would you want to add? And then I asked the speakers beforehand, right? I gave them some warning. About these questions, which one are you most keen on answering? And no one picked my favorite question, which is, what one feature would you like to remove from Julia? And I'm going to, even if you didn't prepare, anyone want to venture anything there? Maybe from the audience. It'd be good, if no one wants to say anything, it's fine, right? It means Julia has nothing it shouldn't have. That's, sorry? Do you want to, is that a flippant remark, or is there a serious...
Well, it still gets used too much, but it's in there and it needs to not be used. At async, which was always bad, and everybody knows it's bad, but people keep using it.
And what is it? What's the problem? For the
use at spawn instead.
Okay. Okay, so I think then we've learned that Julia is a pretty good language, and I want to thank the panel very much and all of you for attending, and we'll see you around.